First thing first, there is no official certification for CCNP or CCIE switching. Earlier, we used to have a dedicated exam for the CCIE switching, but nowadays, like we do not have like any dedicated exam for the CCNP or CCIE switching. So the content that we are going to cover under the switching, it is going to be like CCIE Enterprise Infrastructure switching. So the content from the CCIE Enterprise Infrastructure, that's what we are going to cover under the switching section. So let's first talk about the content. Let's first see like what things we are going to cover, and then we will proceed like accordingly. So if you search like CCIE Enterprise Infrastructure, current exam is basically version 1.1. So if you just search CCIE EI 1.1 and just click on the first link that we have, here you will see some content about the switching. So CCIE Enterprise Infrastructure, and the very first section here we have in the network infrastructure, we have the very first topic, which is Swiss campus. This is going to cover all the switching related topics that we have here. That's what we are going to focus on. This is the content, as you can see. This is the content that we are going to focus on here. So see, if you just search like CCIE EI 1.1, this is the official CCIE Enterprise Infrastructure, current version 1.1. And if you just click on the very first link from the Cisco, so this is like Enterprise Infrastructure Exam 1.1. Since we do not have like a dedicated certification exam under the switching anymore, earlier we used to have like CCNP routing, CCNP switching, CCNP T-shoot. Those exams were there. So there used to be a dedicated certification exam, but nowadays we don't have like a dedicated switching certification exam. So we are going to cover things from like CCIE Enterprise Infrastructure version 1.1. This and also from the CCNP, if you talk about, there is a core exam, that is what we refer to as ENCOR exam. So if you search like on Google, like ENCOR, like this is 350-401, which is more like the written exam for the lab exam. So 350-401, this is the ENCOR exam, Enterprise Core. This also covers like a few topics of the switching. So we are going to also cover that. Basically, we'll make sure that our content covers like everything. Everything means like everything from the switching point of view, so that you will not need like any further more classes for the switching. So we are going to focus on the ENCOR exam. We are going to focus on the CCIE Enterprise Infrastructure exam, and we'll make sure that everything from here is covered. Again, from the switching content point of view, it's completely overlapping. Like whatever things are there in the ENCOR exam regarding the switching, it's completely there in the CCIE Enterprise Infrastructure. We will see in a moment, but it's completely overlapping. So whether you cover this or you cover this, it's basically the same thing. They have also like, by the way, just in case if you want to take the ENCOR exam, or if you're planning to take the ENCOR exam, understand that they have by the way changed the content of the ENCOR exam. So starting from March 18th, starting from the March 19th, by the way, in coming approximately 2 months, the ENCOR exam version 1.2 will launch. And in this ENCOR exam version 1.2, what they have done, they have removed all the wireless section. Earlier, the ENCOR exam used to cover the wireless as well, because it was a common exam for enterprise infrastructure and enterprise infrastructure wireless, or enterprise wireless. Basically, it was a common exam. It was a common written exam for the enterprise infrastructure lab and enterprise wireless lab exam. But now what they have done, they have basically separated the wireless content. So we don't have like, we'll no longer have the wireless content in the new ENCOR exam version 1.2, but that will start from the March 19th. Switching section, however, is common. So whatever things we have here, so if you just go through the content for a moment, like under the architecture here, this is the switching part. Explain the different design principle used in an enterprise network, such as like 2-tier design, 3-tier design, what is fabric, what is cloud. Explain the HA techniques, high availability techniques, such as like first stop latency protocol, something called stateful switchover, SSO. So this is, by the way, switching content, which we will cover as a part of our content. Then wireless, we will not cover, of course. Then the SD-WAN, we will not cover, of course. SDA, we will not cover, of course. QoS will not cover. Describe the hardware and software switching mechanisms such as CEF, CAM, TCAM, FIB, RIP. This part will be covered, by the way. So under the switching content, this part will be covered. So we'll cover 1.1 and then we'll cover 1.6. Then we'll move on to the virtualization. In the virtualization, we do not have anything regarding the switching. So this is VRF, GRE and all that, list, VXLAN. So we do not have anything under the virtualization section regarding the switching. So nothing from this section will be. Then infrastructure, here we have the layer 2. So here we have some layer 2 techniques such as .1Q trunk, ether channel, static, dynamic, STP, RSTP, MSTP, STP enhancements features such as root guard, BPD guard, So basically layer 2 operations, we will cover this as a part of our content, the part of the routing, not switching. This will not be covered. It is part of the wireless, so will not be covered. This will be covered, by the way, HSRP, VRRP. That part we will cover. We are only going to focus on the layer 2. By the way, from this content, we are not going to cover the layer 3 section, or we are not going to cover like NAT, PAT, PIM, and all that thing. We are not going to cover that. These are all part of the routing. So these are covered specifically in the routing and at the end of the routing. So we are only going to focus on the switching section for the moment. So from the content, from the ENCOR content, this part basically we are going to cover. Try to rejoin once, see if it is still there. Others, are you still facing the issue regarding the voice? Is the voice breaking up for the others as well? Others like Amit, Prateek, is it okay or is it breaking? So we are going to focus more on the switching section. We are not going to talk about the rest of the things. So yeah, routing and all that part we are not going to cover. So here from this infrastructure section, we are going to focus on the layer 2, and then we are going to jump to the FHRP, first hop redundancy protocol, like HSRP, VRRP. They have removed, by the way, GLBP. So gateway load balancing protocol is no longer part of the content. They are focusing more on the HSRP and VRRP now, more like ones that we use commonly in the production environment. So that's what we have to focus on. Other things such as like multicast routing, PIM, and all that thing, NAT, PAT, NTP, PTP, all these things are covered in the routing or at the end of the routing. So will not be covered here in the switching content. Then the assurance we have here, under the assurance we have span, RSpan, ERSpan, these techniques, span, RSpan, ERSpan. These are the port mirroring techniques. That's what we are going to cover. We will cover these span, RSpan, ERSpan. Rest like DNS Center, NetConf, and all that thing, they are not relevant from our switching content point of view. So we're not going to talk about that. The only thing that we will cover from here under the switching is going to be this span, RSpan, and ERSpan technique. Under the security, we do not have anything that we have to talk about here, actually. .1x, MAB, WebAuth, like these things are covered specifically in the security section. .1x you will see in the SDA later on. So control plane policing, ACLs you will see in the routing. AAA we talk about in the routing, and also we don't have like anything that we have to cover from this section under our switching. Most probably we are going to let's see, like if some topics are there in the PPT, then we'll talk about it. Otherwise we are going to cover these things in the routing or at the end of the routing. So nothing that we have to cover from here under our switching content. And the same goes for automation programming, nothing that we have to cover from here under the switching. So you can see that the content of the switching is very limited. Like only a few things are there in the ENCOR exam regarding the switching, and similar things are there in the new version 1.2 here. In the 1.2, you have the same exact thing, 2-tier, 3-tier, FHRP, first hop redundancy protocol, stateful switch over, same like then SD-WAN, SDA. They have removed all the wireless section from here, so wireless is no longer there. The virtualization, like same virtualization techniques, same VRF, GRE, same exact thing, no changes here at all. Here what they have done, the same layer 2. No addition, no removal, nothing. Basically, it's the same thing. However, they have removed from here the wireless content that they had. They have removed that content from here in the new ENCOR exam. They have removed it. They have added more topics in the multicast, like multicast, SSM, bidirectional PIM, whatever these are. So they have added a few more topics under the multicast, but they have removed the wireless section completely from the ENCOR exam. So that is gone now. But from the switching content point of view, the things remain exactly the same. Under the assurance, the same thing, like span, RSpan, ERSpan is the only relevant thing that we have to talk about. Under the security, they have removed the wireless security topics, so no longer part of the content. Automation programming, nothing again that we have to talk about from the switching content point of view. So it's basically the switching content remains exactly the same in the old ENCOR exam and in the new ENCOR exam. So everything from this content will be covered in our training sessions. So the ENCOR exam, the switching content from the ENCOR exam 1.1 or 1.2 will completely be covered. And alongside with that, we'll also cover like everything from the switching content point of view from our CCIE Enterprise infrastructure exam as well. Basically meaning to say that once the switching part is done, it's done. Like you will no longer require like any more classes for the switching, whether from the CCNP or CCIE point of view. So like you can see that here in the enterprise infrastructure, the very first section is the switching campus, switch administration, managing the MAC address table, error disable recovery, MTU, layer 2 protocols such as CDP, LLDP, UDLD, Then the VLAN technology, access ports, trunk, only .1Q trunk, no longer, we no longer need to cover the ISL, inter-switch link. The only thing that we have to cover is the .1Q. Then native VLAN, then manual pruning, normal VLAN, voice VLAN. So some VLAN topics, VLAN and trunk topics we have to cover here. Then the Ether channel link bundling techniques. In the Ether channel, we have some layer 2 Ether channel, layer 3 Ether channel, LACP, PAGP, and all that thing we have to cover. Some load balancing mechanism, Ether channel load balancing mechanism, load balancing algorithms, whatever we have. What will happen if we misconfigure the Ether channel? What will happen in that case? What is this multi-chassis Ether channel? Basically, the Ether channel relevant things we have to cover here. And then the important topic, which is STP, spanning tree protocol, STP, STP, and then RSTP, MSTP. Those things we are going to basically. The important thing basically is that the important topic that we have here is basically the switching. So STP. So that STP topic is there, like PVST, rapid PVST, MSTP, port priority, and all that thing. So this is what we are going to focus on. This is the only part that we have under the switching. That's it. So under the switching campus, we don't have a lot of topics. This is just these are the main things that we have to focus. And then if you scroll down, then it's all routing. So it's all routing, software-defined networking. No need to worry about that. Infrastructure security, and under the infrastructure security and services, what we are going to talk about, these features: VACL, VLAN access list, port-based access list, TOM control, HCP snooping, basically these things, these options we are going to talk about. This is called layer 2 security. So we will cover these layer 2 security topics in our switching content. This is part of the content, so we will talk about it. Apart from that, nothing that we have to talk about in our switching content. Span, RSpan, ERSpan will be done anyway. Then that, what is that? HSRP, VRRP will be done anyway. So that is, I believe, pretty much it. So as you can see that the switching content is not that much. Earlier, we used to have a dedicated exam where we had like a lot of switching content. Like we used to study the protocols such as VTP, VLAN trunking protocol, DTP, dynamic trunking protocol, GLBP, gateway load balancing, private VLANs, and all that. But they have removed, slowly, they have removed all those content. So this is the only relevant information that we have to talk about. This is the only relevant content that we have to talk about from the current exam point of view. Current exam CCIE Enterprise Infrastructure 1.1 and the ENCOR exam 1.1 and 1.2 point of view. The rest of the things, they are not talking about the rest of the things, such as we are not going to talk about ISL trunk. We are not going to talk about the private VLANs. We are not going to talk about the GLBP. We are not going to talk about like VTP, VLAN trunking protocol. Why? Because it's basically not part of the content. We earlier used to have those topics. We don't have those anymore. And the reason you will understand throughout the content, you will understand that why they have removed those features. Things are slowly moving towards the routing-based technologies rather than switching-based technology. So less and less switching things we need to know now, because when we talk about the design, companies are basically moving away from the STP-based design to some routing-based design, which we will talk about. But you will understand throughout the content that why they have removed those topics. For example, like DTP, VTP, these are proprietary things. These are proprietary only to Cisco. ISL is no longer a standard protocol. Even the new Cisco switches, they don't even support ISL. So they have removed all those things that were not so much relevant from the production point of view. I would not say like VTP is not being not completely not in use, but since it's a proprietary thing, only Cisco devices, Cisco vendor is able to use it. So it did not make a lot of sense actually to still use it in the content. They removed it basically again. So this is we have to be very clear on the topics that we are going to cover. So these are the things that we are going to talk about from our switching content point of view. Rest like the routing section, the monitoring and all that thing we will talk about like later on. But switching content is very limited, very small. I believe it will take maximum 22 to 24 classes max, based on how many questions, how many queries you ask. 20 to 24 classes maximum. 20 to 24 classes it will take maximum to complete the classes by the way. 20 to 24 classes it will take maximum to complete the content, and we will have the classes from Monday to Friday. at least for this month. Classes are normally from Monday to Thursday actually, but I will be on leave for some days, so I'm going to compensate it, beforehand. So we will have the classes from Monday to Friday, at least for this month. Monday to Friday we will have the classes. Saturday, Sunday you can do the practice and all, and we will try to complete it within, I believe, like 1.5 month maximum to maximum. It will not take more than that much time. Maximum to the entire switching. Like again, you will no longer need any more classes for the switching. The complete CCNP-CCIE switching will maximum to maximum be covered in 2020. I would say like Monday to Friday, if I go like then I guess like 1 month, 1.5 month. It will still take 1.5 month, like, but it will be done. Because you will notice that, for example, the STP topic, the spanning tree topic, although we don't have to do a lot of things in STP, but when we start doing when we start going through the concept, it takes like quite a lot of time to cover the STP. Like first we'll talk about STP, then PVST, then PVST plus, then why do we need rapid PVST? So it takes like whole week, like whole 4 or 5 classes to complete just the STP. Then 2-3 classes it takes, like 2 classes at least it takes for hold fast, BPDU guard and all that thing, STP protection feature. A few 2-3 classes it takes for the ether channel and all that. So overall 20-22 classes, 24 maximum I would say, since they have removed like a lot of content from here. So I would say 20-24 classes maximum it will take to complete the switching. It will still take 20-22 classes, even though the content is not that much. But when we start covering the things, you will notice that since we are going to talk about like from both CCNP and CCIE point of view, so in some quite detail we will go. It will still take like that much time. 20-22 classes, 24 classes at least. Right. Again, repeating, we will have the classes Monday to Friday, like for at least this month. I will be on leave for a few days. I will inform you before like beforehand. Like I will inform you. We will. I guess like I will have the off for like 2 days, so I'm going to compensate it like beforehand. So we will have the classes from Monday to Friday this week, next week, next to next week, basically. So so that like you don't miss out the or the content basically is covered in within the time period. So this is the content that we are going to talk about, and most of from the lab point of view, you can do like all the labs of the STP. I would say like approximately 99% of the things you can do in the EVNG. So you will not require like EVNG, or maybe a few things work in packet tracer, does not work in EVNG, by the way. I generally do not recommend anyone using the packet tracer, but for a few things you can still use the packet tracer. I will let you know what exactly are those things, but 99% of the things like you will be able to complete in EVNG. Only a few set of commands, only a few things do not work in the EVNG, such as storm control. The switches that we have in EVNG, they do not support this storm control feature properly. Some commands of like storm controls are not there. Different images needs to be tried on, but storm control you will most probably not be able to implement. Similarly, like test ether channel command. A few commands basically are not there in the EVNG, but rest like all the things like you will be able to practice in the EVNG. Templates, SDM, switching database manager, we'll talk about it. SDM templates you can't practice in the EVNG. So we will talk about a few things that you can't practice in the EVNG, but other than that, approximately like I would say 99% of the things from the entire switching content, you will be able to cover in the EVNG. Even later on when you cover the security, even things such as .1x, 802.1x is now supported on the EVNG. So like pretty much like everything you can practice in the EVNG, except for a few things such as storm control, SDM templates. Sometimes that VLAN access list sometimes does not work if you're not using the proper switches. So I will let you know which version of the iOS I'm using in the EVNG. You can download and install the same version. In that version, you will notice that approximately 98-99% of the things will work without any problem, right? And if you're coming here offline, like then you can also practice on the racks now. So on the hardware devices, if you want to practice on, you can do that, but for that you have to come here offline for the classes. But if you're joining online, then you will be able to complete like 99% of the things in the EVNG itself. Only a few commands will not work that you can safely practice either in your controlled, like in your simulated environment, like maybe commands you can see from the documentation, like Cisco official documentation, what are the syntax for the command, and later on, whenever you get the chance to implement that command, you can run it. But those are not going to be like anything relevant from the exam point of view. Nothing that they have asked in the exam that you cannot practice in the EVNG. whatever they have asked in the exam, you can practice in the ENG. So this is the content. This is the approach. There is no predefined lab, by the way. There is no predefined lab as we have in the routing. We do not have like any predefined lab in the switching. We'll start talking about like designing the campus area networks. And when we are talking about designing from 2-tier, 3-tier, we will design the campus area network and we'll stick to the same topology. Basically, we will design the network from the scratch. We'll take a few switches, we'll connect them together, we'll configure the VLAN trunks and all that in there in the same, and we'll work on the same. So there is not going to be like any predefined topology like we had in the routing or maybe in the SD-WAN or in other classes. We are not going to have like any predefined ENG file or predefined topology. We'll work from the scratch to build the lab. You will do the labs on your own machine, by the way. And if you do not have ENG setup, you can practice this switching thing in I believe like even if you have like a basic 8 GB RAM, that is still enough. You don't need like a lot of RAM, a lot of resources. Even if you have like 8 GB RAM, you can easily practice like all the switching related things. You have to have the ENG installed with you. If you don't have ENG installed with you, you can drop a message to your accounts handler, accounts manager. They will connect you to the lab admin and they will basically install the ENG on your machine by taking the remote access. So they will provide you an OVA file. You can just download that OVA file. It will include all the relevant images. Otherwise, you can just drop them a message that help us with the lab setup, and they will take the remote access and then they will do the things. So if you don't have ENG on your machine, you can drop a message to your accounts manager. They will connect you to the lab admin for that lab setup. Objective will be whatever we do in the classes, you have to repeat it as it is done. Like whatever we do in the classes, you have to repeat it as it is. Whatever like theory part we talk about in the classes, whatever theory we talk about in the classes, whatever labs we do in the classes, you have to repeat it as it is. And if I ask, for example, certain question in the class regarding the technology, it is your responsibility to find the answer to that question by doing the labs, by doing like by going through the documents and all that thing. So it's your responsibility to find the answer to that question, because I will not give the answer to those questions. So whatever we do in the lab or whatever we do in the classes, you will have to repeat it as it. Objective is not to configure the VLAN. Objective is not to configure the trunk. Objective is not to configure the STP and all. Objective of this CCNP-CCIE switching content is basically to understand the technology. It's not like a task solution approach. It's not like that. It is not like I'm going to ask you to configure the VLAN and then trunks and all. So the objective is to understand the technology, the why that is happening behind the technology. That's the objective. And for that, like you don't need to follow any workbook or anything. Just simply whatever we do in the classes, just follow it as it is. Whatever theory we talk about in the classes, you revise it from the documents, you revise it from the video. You will have the recorded sessions. The session is being recorded. So once the class ends, you will get the recording in your portal. Not immediately, after like 3-4 hours, you will get the recording in your portal. So whenever you get some time, you can revise the things from the recording. If you want, you can create some short notes. If you want, you can make some notes, and then following the recordings, whatever labs we have done, you can repeat the labs in the ENG. Try to repeat exactly the same what we have done in the classes. Try to understand the technology. Try to do the packet capture and all that thing. Do not follow like any task solution approach. Not at least as of now. First, try to understand the technology. Then later on, like whenever you get the chance to solve some questions, there you are going to follow the task solution approach. At the moment, you don't have to do that. And for the documents, for the books, actually, unfortunately, there's no like official book for CCNP switching. So if you want to study from certain document, like if you want to learn more about the technology and you want to refer to certain book, actually the ENCOR book you can have basically this enterprise core book and ENCOR official certification guide. Basically you can have the ENCOR exam official certification guide. This ENCOR official certification guide that we have, this is going to include certain switching content. So here, by the way, for example, this is the ENCOR book, second edition. This is the ENCOR book. And from here, if you go through, you will have some basic packet forwarding thing. There they have talked about like how two devices basically communicate, trying to let you know, trying to revise the TCP/IP OSI model, then how the layer 2 forwarding happens, how the layer 3 forwarding happens, what is this process switching, what is this fast switching, what is this SEF. We'll talk about all these things. What is this SDM templates and all? This is relevant to the switching, so you will have to cover it. You can cover the basic fundamentals of the switching from here. Then you can see that they have directly started the STP, which is not ideal. So after the packet forwarding, you have to start the VLAN and trunks here, the chapter number 5, VLAN and trunks. What is VLAN? What is trunks? They have also included the VTP protocol, which is not part of the content. You can safely like ignore it. What you have to study from here, you have to study about the VLAN, you have to study about the trunks, you have to study about the Ether channel. You don't need to worry about the VTP, VLAN trunking protocol. If you want, you can go through it. What is the VLAN trunking protocol, how VTP communicates and all. Just like 1 or 2 commands, but it's not part of our content. It's not in the official certification exams. So they have included it in the book, but it is not part of the content. So you can, or you might, or you might not want to cover it. Completely up to you. So after the basic packet forwarding, don't go for the STP, go for VLAN and trunks topic. Once you have completed the VLAN and trunks topic, then you come back to the STP, spanning tree protocol, then advanced spanning tree, like how to configure the root bridge, how to configure the root port and all that. And then finally the RSTP and MSTP. So overall, only like 5 chapters are there. Overall, 5 chapters are there. Basically the part one, where we have the chapter 1, packet forwarding, chapter 2, spanning tree protocol, chapter 3, advanced spanning tree protocol, chapter number 4, multiple spanning tree protocol, and chapter number 5, VLAN and trunks. These 5 chapters are relevant from our switching content point of view. So if you want to cover the things from the books, from the documents, this ENCOR book, the first 5 chapters of this ENCOR book, you can go through to get more and more knowledge about the switching. And then it's all routing. Then PIM and whatever, like it's all basically the routing. From the design point of view, actually, you will have from the design here, enterprise network architecture. Once you have covered those 5 chapters, then you can go for the chapter number 22. In the chapter number 22, you will have that 2-tier design, 3-tier design, HA, all that thing, STP based, routed access layer, a little bit about the SDA as well. So once you have covered the first 5 chapters, then you have to directly jump to the chapter number 22, which is in the ENCOR exam. It is for the switching as well. You don't need to worry about the SD-WAN SDA. You can ignore it. Don't need to worry about that. But the chapter number 22 focuses on the design, 2-tier design, 3-tier design. That you will have to cover. This part you can cover from the book as well. Then here, the span, RSpan, ERSpan, those things basically. Span, RSpan, ERSpan. This is in the chapter number 24. In the chapter number 24, you have that span, RSpan, and ERSpan technology. So we have span, RSpan, ERSpan. Those things are there in the chapter number 24. So you can cover those topics from here, from the document point of view. Then you actually don't have anything else. Virtualization, yeah, forget about it. That's pretty much it. First 5 chapters, then chapter number 22, and then in the chapter number 24, the span, RSpan, and ERSpan topic. There is also going to be some security topics with security. In the security, the ACLs, the VLAN ACLs, the port bridge access list, the VLAN access list, the security topics are basically here. They have not included the layer 2 security, like DHCP snooping, dynamic ARP inspection and all. Somewhere they might have mentioned it, but you can cover like all the relevant information pretty much from the ENCOR book actually. From this ENCOR book, Enterprise Core book, either the first edition or the second edition, you can cover like plenty of things, like pretty much like I will not say like everything. You can complete like pretty much like again a lot of things of our official content from this ENCOR book. And if you want to have like a very much detailed like discussion, then you can go for old like CCNP switch exam old book. This is the old book, by the way, 642-813. This is an old book basically. Might not be relevant from the current content point of view. It's a very old book, by the way, but if you go through the content of it, it's really very relevant from the current content point of view as well. So it focuses specifically on the switching. So if you want to know more in detail about the switching, you can definitely go for this book as well. This is CCNP switching. This is the old exam book. So you can see the same, the design. Not here, the chapter number 2. Chapter number 2 is basically like the design, the switch operation, the address learning, filter and forwarding decision, the loop avoidance, the tables, the CAM table, TCAM table. So the switch operation, then the port switch port configuration, what is Ethernet, what is fast Ethernet, what is gigabit Ethernet, 10 gig Ethernet, what is like duplex, what is like speed, what are different error conditions and all that. So switch port configuration. Then you have that VLAN and trunks topic, a dedicated topic for the VLAN and trunk. Here they have talked about both .1q and ISL, because in old switches, like we used to have both of the protocols, .1q and ISL. So here they have talked about like both .1q, 802.1q and ISL protocol. So both things are there. They also have talked about VTP, by the way, VLAN trunking protocol, although it's not relevant. But if you want to know about it, if it is being used in your production environment and you want to learn it, you can definitely go through this chapter as well. But from the current exam point of view, they don't have any questions, or they do not have like any topic regarding the VTP, VLAN trunking protocol. Then Ether channel. What is Ether channel? Layer 2 Ether channel, Layer 3 Ether channel, the protocols, PAGP, LSCP, a dedicated chapter for the Ether channel. Then if you go down, then the STP, the traditional spanning tree protocol. Then they have STP configuration. Then they have RSTP, STP protection, how to protect the STP, root guard, BPD guard, and all that thing. Then advanced STP. Under the advanced STP, they have the rapid STP, rapid spanning tree protocol. Then MSTP, multiple spanning tree protocol. So quite in detail about the STP, like 3-4 chapters of like STP dedicatedly. 3-4 chapters dedicated for the STP. They have in this particular book that you can go through. Then in the multi-layer switching, they have talked about like that Ceph, Cisco Express Forwarding. What is this DHCP? How the DHCP works and all that thing. InterLAN routing. So in the multi-layer switching, they have talked about these kind of things. Then the design. Then the 2-tier design, the 3-tier design. The design part is in the chapter number 12. So chapter number 12 includes the design section basically. So design you can go through. HA, high availability, HSRP, VRRP. They also have the GLBP, which is no longer part of the content. But again, if you want to go through it, you can go through it. So GLBP is also there. And then they have PoE, voice VLAN. Then they have QoS, quality of service. Again, not something that we have to configure, but you can go through it like, although it's part of routing, but you can, since we can also configure the QoS on the switches, they have included a few things regarding the quality of service, specifically from the voice traffic point of view. So if you want to go through that, you can definitely cover it from the book. Wireless, again, no need to worry about the wireless. You can ignore it. Then here they have all the security features like DHCP snooping, dynamic ARP inspection, IP source guard, like port-based authentication, .1x and all that thing, port security. So the layer 2 security, the L2 security. The layer 2 security topics are here under securing the switch campus network. This definitely you should cover. Then the VLAN access list, the private VLAN and all that thing, all that thing basically. So there are basically 17 chapters in this book. There are total 17 chapters that you can go through. If I ignore a few chapters that are not relevant from the current exam point of view, still you will have like total 15 chapters that you can basically, or you will have to cover again from the exam point of view. So if you want to know like in more details about the content, you can definitely look up for this old book, this old document, this old book as well. So basically you can complete the things from the ENCOR book, or you can complete the things from the CCNP switching book. You will get like pretty detailed information in both of the documents, in both of the books. I would recommend that you go through this book first, this CCNP switching book. And then if something is left, then you can cover it from that ENCOR book. This book will give you like more and more information as compared to that ENCOR 1.1 or 1.2, or basically first edition or second edition. It's quite in detail. Again, not everything is relevant. So I would not say that you go through like each and every topic. You can go through the content, official content, and maybe from there you can find out like whatever things are relevant, and then you can cover on those things from this official documentation. It's old exam, it's old book, not relevant from the current content point of view. It's like approximately 15-year-old book. So it's 2010, approximately 16-year-old book. So might not be completely relevant, but still a lot of topics are there which is still relevant from the current exam point of view.
Just like you mentioned that there's a change in the written exam. Is there any change in the lab exam as well?
No, currently there are no changes in the lab exam. It's still 1.1. So it's still all the things that we have discussed. Only those things we have to. Some more details if you want to go through, like CCI. If you can search the old CCI version 5, volume 1, official certification guide. This also includes some topic of the switching. So sample content. So here you can see the very first chapter is in fact the Ethernet. So Ethernet layer 1, layer 2, what is frame, then the span, R span, ER span, the 2-tier, 3-tier, the VSS, multi-chassis or channel, then the VLAN and trunks. At least in this book, chapters are like neatly arranged, properly arranged. So VLAN and trunks, ISL and .1 queue. We don't need to worry about the ISL, but we have to cover the .1 queue. VTP is not part of the content. You can ignore it, or you can go through it if you want to from your production point of view. Then the STP, the complete STP. So there are like total 3 chapters in this book for the switching. But in this STP, the detail that they have gone through, that they have gone like for the MSTP, like they have gone in very detail about the MSTP in this particular book. So I will definitely recommend that if you want to learn more and more about the MSTP, multiple spanning tree protocol, then you definitely go through the MSTP content from this book. There are only five pages, 4-5 pages, and it will take like at least 1 week for you to understand what they are trying to say. But it is very much in detail, very much in detail. There are only 4-5 pages. Only 4-5 pages for the MSTP, then interoperability between all the STPs, which we will talk about as a part of our content. We will take some time. We will definitely cover it, but they have gone through like in very detail about that topic here in the book. So you can definitely cover it from there. So if you want to study like if you want to go through like in more detail about the MSTP, you should definitely go through this document as well. Only 3 chapters. Then it's all routing. So this is again old version of the CCI routing and switching. When CCI when it was known as routing and switching rather than enterprise infrastructure. So there in the volume 1 we had that detailed discussion about the STP, RSTP, MSTP. So you can definitely refer to some topics from here. So basically, you can study from the content from the theory point of view. You can complete the content from the ENCOR book, the core exam. It's simply ENCOR. You can study from the CCNP switching, which is old book, or you can complete a few things like CCI routing and switching, old exam. Well, version 5, volume 1. This will pretty much cover like everything that we have to know from the switching point of view, from both CCNP and CCI level. And once it's done, again, the complete switching part will be done. You will again, like I said, you will not require like any more classes for the switching after these 24 classes. It will be like completely done from the content and maybe from your production point of view. A few things such as like private VLANs, a few things such as, for example, VTP, a few things such as GLBP, ISL, a few things we are not going to talk about. So if they are relevant from your production point of view, you will definitely need to study it from the documents, from the videos and all that. But since it is not part of the content, we're not going to. So basically, I'm trying to clear the expectations about the things that we are going to cover, about the things we are not going to cover, so that you have a clear idea about the content, about the topic. You can download it also. You can download this PDF file. You can download this PDF file. You can download this ENCOR document, ENCOR content PDF as well, and make sure that everything is basically covered from our content. It's a very small topic, by the way, but still 22 classes, it will be completely can be practiced in the ENG environment. You will not require like any additional software or anything. However, like sometimes we might need to use the packet tracer. Sometimes we might need to run commands on the real devices that I will show you. You might not be able to practice it in the ENG, but whenever you get the chance to practice or run those commands in the production environment or on the real switches, you can run it, or you can simply refer to the documentation, and you can cover it from there as well. So this is the discussion about the content that we are going to cover. Anything, any queries, anything. If you have any point you want to discuss, anything that does not make any sense, any questions we can discuss.
Yeah, hi Surinder sir.
Yeah, hi, Rajita.
Yeah, hi Surinder sir. I have one question. So there are workbooks which have been provided to us, right?
Okay.
But I was referring to your videos, which is like 3 or 4 months ago. The workbook
Hmm.
topologies and the topologies which you have,
Hmm.
used for study purpose. I mean, they are not matching.
Yes, correct. That's what we have discussed in here. Like what we have to do, what you have to do basically, you have to repeat all the things that we do in the classes as it is. You don't necessarily need to follow the workbook, not at least like initially. Once you have gone through all the technological things, then you can use that workbook. There's a different topology in that. You can take that topology, you can take that basically you can build that topology. You can then follow the workbook and then do the task solution. It is not going to match from the video or from the, because in the classes we cover the technology content. We don't like work on a predefined topology. The workbook is
Yeah,
basically
exactly.
based on the predefined topology.
But those workbooks are matching with the 3-year-old topologies which you have
Yes,
taught.
yes, yes.
So
At that time, we were using that approach, but since the content has changed, since they have removed a lot of topics, since they have changed the content of the enterprise infrastructure, like in 2021, basically, they are definitely not going to match. We continuously like change the topology. If you go through even the routing section, if you watch the recordings of the routing 3 4 years back, it is not going to match with the current.
yeah, so you're going to provide us the new workbook, or?
There is no new workbooks. There are no new workbooks. You have to follow the documents. You have to follow the recordings. You have to follow whatever we do in the classes on regular basis. So you have to, whatever labs I do in the classes, you have to repeat it in your own simulated environment as it is, maybe in EVNG or in the real devices, whatever. You have to do the packet captures. You have to basically repeat everything that we do in the classes as it is in your home environment. It's not, there is not going to be like any task solution approach. We are not going to do that. So there is not going to be any workbook for the technology training that we are going to have throughout the content. It's also not there for the routing. It's also not there for the switching actually. Once you have gone through the technological training completely, then you can basically refer to that workbook that you already have. You can build that topology, you can follow the questions, and then you can do the research. But for next 2022 classes, 24 classes, you have to follow whatever I do in the classes. You have to repeat it exactly the same in your home environment in the evening. That's the approach that we have.
Okay.
Yes. Then by the end of the content, once it's all done, once you have the technological understanding of each and everything, then you can definitely refer to the any workbook, any documentation. You can follow that from the practice perspective. Objective is not here to complete switching in any predefined topology. Objective here is to understand the technology. We might not stick to the same topology. Like so, we might for example for the VLANs and trunk, we might use a simple straightforward topology of 3 4 switches. But for the STP, we are going to use more complex topology. For the Ether channel, I might use only 2 switches. So there is not going to be like a predefined topology that we have to work on. So just repeat whatever I do in the classes as it is. Try to get the concepts clear. Try to do the packet capture and all that thing. And once your fundamentals are clear, once you are done with all these things, then you can follow the workbook, build the topology that is there, and then you can repeat it, or you can revise the things from there. Workbook is more like for the revision rather than following it along with the classes. That's not why we have that workbook for. So first we'll clear the technological concepts, then you can follow the workbook. That's the approach we are going to. So you'll have to be available in the classes. You'll have to be, or if you're not present in the classes, then you can revise the recordings. You can cover the things from the recording, and then you can practice from there. More queries? Let me know. More questions from the content perspective, from the content point of view. More things if you want to know about, let me know.
From the exam perspective, is this? I mean, uh, how much is covered in the lab?
There's no predefined lab for the switching. So once we have covered the technological aspects, the exam will come like anyway. So from the exam perspective, from the exam topics, like they're not like a lot of things that they have asked. So if you've gone through the technological training, it will be done like anyway. So we're not going to have like any predefined topology by the way. We're not going to have like any predefined topology for this. We have to understand the technology. We have to go through the technology. Once the technological part is clear, then you can cover the same things in the exam.
Do we have
Uh,
do we have switching QoS also? Switching QoS and switches.
we have covered it in the classes, in the
Yeah,
routing classes.
yeah, routing. Yeah, so
Yeah.
I mean, in the switches also, do we
No,
need
no,
to configure?
no, we are not going to have the QoS in the switching.
Sundar sir, one more thing. So
Yes, yes.
to configure these labs, we need to connect with the backend team. team, right?
Yeah.
On the laptop.
Again, like there's no predefined lab also. So if you want to install the EVNG on your machine, then you can drop a message to your accounts manager. They will connect you to the lab admin and they will install the EVNG with you on your laptop by taking the remote access and all that. But there's no predefined topology. So we will build a topology from the scratch. So there's no UNL file or anything like that. For the installation of the EVNG and the images and all that, you can definitely drop a message to the accounts manager, and then they will definitely.
And these switching, routing, and SD-WAN labs, that can be done over the EVNG, right? Completely, or you're going to provide some extra access like for SD-WAN or something?
SD-WAN will be discussed in the SD-WAN. Routing will be discussed in the routing. But just a general idea, like you can practice the routing and switching in your home environment. For the SD-WAN, you will require like good amount of resources. If you have good amount of resources, then you can practice it. At least like 80 GB RAM, at least 64 to 80 GB RAM on your machine. If you have, then you can practice the SD-WAN properly. Else you will get the access from here on a server basis. Like on 4 hours per day basis, you will have the access for the same. So routing and switching you can practice. But I will not say that you can practice the SD-WAN completely if you do not have like any high resource machine with you. More questions, more queries? Let me know.
I had this lab set up in my laptop, but it's like only 16 GB RAM, which I believe is sufficient for routing switching at least. Do I need to invest in an higher-end laptop for the other SDWAN and SDA classes, or
SDA you can't practice in your home environment. So SD-WAN is the only technology that you can practice in your home environment. For the SD-WAN, you have to have at least 64 GB RAM if you want to practice on some old version of the SD-WAN. Higher versions require like more resources. So for the higher versions, at least like some more RAM, such as 80 GB, at least minimum it is needed. Otherwise, you will anyway like when you cover the SD-WAN, it is discussed that you will get the access of the lab from here as well. So if you don't want to like build a powerful machine, you can get the lab access from here. They will provide you the lab access 4 hours per day. You can practice all the SD-WAN related things in that lab only. So you don't need to spend like money on the lab. But apart from that, other
so
things you can practice.
this SDA part also I will get access to the lab from the.
You will not get the access of the SDA. That is only more like it's at the moment it's mostly on the hardware. So we don't provide the lab access for the SDA. It's just the technology for you. Will be discussed in the SDA section. More questions? Let me know. All right. So we already have discussed about the basics, like what things we are going to cover. Again, you can find the details from the Cisco website, or you can refer to the recordings later on. So let's start with the basics, like what exactly is switching, what types of switches we have, how to take the access of the switches. That's the basic stuff that you might already know. But anyway, let's cover it. So first thing first, what is switching? Forwarding of the frames based on the layer 2 address is known as switching. Layer 2 address basically means the MAC address. Layer 2 address basically means the MAC address. So whenever a device receives the data and it is able to forward the data based on the MAC address from one port to other port, from one interface to other interface, that process of forwarding the frames based on the layer 2 address or the MAC address is what we know as the switching. And the devices that forward the frames based on the layer 2 address, they are known as the layer 2 devices. A very common layer 2 device is a layer 2 switch. And before the switch, we used to have this thing called bridges. Before we were having like this technology called switch, we used to have the technology called bridge. We used to have the devices called bridge. Switches are more like successor to the bridges. Switches are more like just multi-port bridge. Switches, in other words, like they are just multi-port bridge. Just like the bridges, switches can also do the packet forwarding based on the layer 2 address. Layer 2 address basically means the MAC address. But things have evolved a lot. So nowadays we have not only a layer 2 switch. A layer 2 switch can forward the frames based on layer 2 address only, which is the MAC address only. Layer 2 switches can forward the data based on the MAC address only. Basically, they cannot perform something called routing. They cannot like forward the data based on the layer 3 address, IP address. They can't perform the routing. Layer 2 switches are able to forward the frames based on the layer 2 address only. Layer 2 address basically means the MAC address. They are not capable of doing the packet forwarding based on the IP. So layer 2 switches. If I go by the old platforms, in old days, we used to have these 2950, 2960. These switches basically, they were categorized as the layer 2 switches. Very popular. Still, you can see these 2950, 2960 in some training environment, in some lab environment. Not very popular in the production environment, no longer being sold and all. But these 2950, 2960 series switches, these are like very popular switches for the layer 2 switching. They are categorized as the layer 2 switches. They can do the packet forwarding based on the layer 2 address, which is the MAC address. And then came in the market this thing called layer 3 switches. Layer 3 switches are those switches that can do the packet forwarding not only based on the layer 2 address, but also the layer 3 address. Layer 2 address basically means the MAC address, and the layer 3 address basically means the IP address. That means the layer 3 switches are equipped with the hardware that can perform both switching and routing. The hardware for the routing and switching, the components of the routing and switching, they both are present in that layer 3 switch, making it able to forward the data at layer 2, as well as able to forward the data based on the layer 3 address or basically the IP address. So the layer 3 switches can do the packet forwarding, and they can also do the frame forwarding. They can forward the frames based on the layer 2 address, and they can forward the data, they can forward the packets based on the layer 3 address. Basically, they can do both routing and switching. If I go to those old platforms, then 3550, 3560, 3750, 3760, 3850, 3860, very popular like L3 switches that we used to have in the market. In fact, 3650, 3850, these are still in use in the production environment. You can still see, although like if you're talking about if you're talking about a complete new deployment, you might not see these switches, but in some production environment, you will still see the old 3650, 3850, these switches. There is a reason for that, but you will see that. We generally used to say that the switches that start with number 2, they are layer 2 switches, and the switches that start with the number 3, these are the layer 3 switches. Not entirely true, but it was like pretty much true. Not entirely, because for example, in 2960, later on what Cisco did, Cisco released an image for 2960 that makes this 2960 capable to perform routing as well. Like some basic routing functionalities are there in 2960. So we can't really categorize it as a pure layer 2 switch, since no longer in use, we don't need to talk about it. But generally, we used to say that the switches model that start with number 2, they are layer 2 switches. We had a perception that the switches that start, the model number that starts with 3, these are layer 3 switches. However, there was no such thing. It was just more like a easy method to identify whether it's a layer 2 or layer 3 switch. Layer 3 switches, however, cannot, people basically call like the layer 3 switches as the multi-layer switches, because they work at multiple layers of the OSI model. They work at layer 2 and layer 3 of the OSI model. So people, they call L3 switches as the multi-layer switches as well. So which is okay. But the true multi-layer switch basically can not only do the packet forwarding based on the layer 2 address, layer 3 address, but it can also do packet forwarding based on a true multi-layer switch can also include the port numbers in the packet forwarding as well, which makes it very suitable to perform functions such as NAT, which are commonly not available in a layer 3 switch, such as 3750, 3650. The function of NAT. A NAT works based on the port numbers. So a switch that is able to forward the data, or that is able to use or include the port number concept, the TCP UDP port number concepts, while deciding how to forward the data, only those switches, only those devices can perform this NAT function. Unfortunately, that NAT function cannot be done on the layer 2 switches or the layer 3 switches. So the multi-layer switches, such as if I go by the old platforms, we had those 45, 47, 48, 65, 67, 68, those old switch platforms under that category, they were true multi-layer switches. So eventually we have 3 types of switches. Like we have layer 2 switches, a switch that can do the packet forwarding, that can do the frame forwarding. A layer 2 switch can forward the data based on the layer 2 address only, which is the MAC address. A layer 3 switch can forward the data based on both layer 2 address and the layer 3 address. And the multi-layer switch can forward the data based on the layer 2 address, layer 3 address, and it can also include the port number in the packet forwarding decision. making it suitable to perform function such as NAT. Can't be done on the layer 2 switches or the layer 3 switches. But this categorization is a thing in the past. Like nowadays, if you talk about like the modern day switches, if you go to the Cisco website and you just search on the Cisco website, like, I just search all switch products on Cisco. If I just search this, I just search all switch products on Cisco. If you talk about the modern day switches, like we don't see those 2950, 2960, or 3750, 3760. We don't see those switches in a modern day environment. In a modern day campus area network, remember that we are talking about the enterprise network. We're not talking about the data center. We're not talking about the service provider. We're talking about the enterprise network. It's enterprise infrastructure classes. So we're talking about enterprise network. Here we commonly use those Ethernet technology-based switches, Ethernet switches. We're not talking about those Nexus switches or data center switches or some Metro Ethernet switches. We're not talking about those kind of switches. We're talking about normal like Ethernet switches that we use in our enterprise environment, enterprise campus area network. So if you just search all switch product Cisco, if you just search and you just click on the first link that you see, you will see like what switches Cisco offers nowadays. So when we have to build a campus area network, campus LAN, campus local area network, we can have some access layer switches. We can have some core and distribution layer switches. We can have some data center switches. We can have some industrial Ethernet switches. We can have, Cisco basically offers different types of switches, different switch products based on your requirement, based on your need. If you want to connect a switch in your data center environment, they have a specific series of the switches for that purpose, data center switches. Typically Nexus series switches are there, work in a completely different way. If you want to place a switch in an industry and an environment that is hostile to normal switch operation, such as, for example, a plant farm where there is too much dust, for example, or maybe a factory where there is too much heat, for example, or maybe there is an environment that is too much cold, there is too much humidity, for example. There, if we connect a normal switch, it might not perform well. So they have made these special switches called industrial Ethernet, IE. These are special switches that are targeted, that are made specifically for industries that work on these hostile environments, such as like very, very cold environment is there, very hot environment is there, dust is there, humidity is there. So these are specific switch platforms that they have made only for those kind of industries. It's not like only Cisco offers these products. Other vendors, they do offer these products as well, like these industrial Ethernet switches and all that thing. But if you take a look at these switches, how they look like, if you click on it, these industrial Ethernet switches, you can just click on it. Click on like these rugged switches, for example, you can click on it and you can see how these switches basically look. These are the switches, these are how they look like. And if you just scroll down, you can find the data sheet. In that data sheet, you can find out like the facilities that they offer, like what properties are there. You can find out from the data sheet. These are one type of switches. Then you have those heavy duty, for example, switches. These are a complete different types of switches. Something like these, for example. These are switches, by the way. So these are basically created specifically for those environments where there is too much dust, there is too much like humidity, there is too much cold, there is too much like heat. For example, if you read the data sheet, if you read the document, if you read the data sheet about these switches, you will know that what kind of environment they can work in. Like, you see, minus 40 degree to 75 degree, minus 40 degree to 75 degree. That is the environment that they can still operate on without any problem. IP6768 rated. That means no effect of dust and like water. No need to go through the data sheet. I'm just telling you that we have different types of switches. We have different types of switches that Cisco basically offers for different types of like environment, such as for the data center, we have, for the data center, they have a different kind of switch. For the enterprise environment, there's a different type of switch. For the industrial environment, it's a different type of switch. You can connect different types of cables on there. Not everyone uses these twisted pair cables. You can connect the coax cable, on these switches. These are switches, by the way. Not necessarily that they are going to work on the twisted pair technology. They can work on, they can still work on the fast Ethernet, gigabit Ethernet, There are different types of interfaces on there, different types of cables are going to be there, but these are still switches. It's not like everyone is going to use that twisted pair cable for the data forwarding. They might use coax cable, fiber optics, or different types of cables that they have for these special switches. But again, this is still a switch. You can read through the document if you want to know what kind of cables, what type of interfaces are there, what is speed and all that thing they support. You will definitely find some information on the same. But again, I would still say that this is still switch. No need to focus on that. But the point is that for a small business, for example, not everyone wants a switch that they want to manage. So you can have some unmanaged switches, these kind of switches that you cannot manage, by the way, starting from only $60. These are unmanaged switches. Just like these TP-Link, D-Link, these vendors that they make, these are like some 110 series unmanaged switches, affordable plug and play, entry level switches, gigabit switches, and all. So these are like unmanageable switches. Unmanageable switches, like you can't manage them via CLI also. So these are for small businesses that might want some gigabit speed, and they don't want to do like a whole lot of 2-tier, 3-tier design and all that. For these kind of environment, these unmanaged switches are basically there. Again, no need to worry about it.
Do they run STP?
Refer to the product documentation. You have to refer to the documentation to find out like whether they run STP or not. Basic functionalities will still be there, definitely. Basic functionalities will still be there, but more details can be found from the datasheet of a specific model to know what capabilities are there. Loop prevention, some loop prevention mechanism will definitely be there. Now, what we have to focus on actually, is that we have to talk about the enterprise switches that we have. The enterprise switches that Cisco offers. So if you want to connect a switch in the enterprise campus local area network at the access layer, you don't see those 2950, 2960, 3750, 3760, those switches, you don't see. The concept of the layer 2 switches, the layer 3 switches, the multi-layer switches is like, almost obsolete. Like, we no longer have a layer 2 switch actually. To be honest, like, if you talk about from the campus local area network point of view, if you talk about, now I'm specifically going to talk about the campus LAN. So from the campus local area network point of view, from the campus LAN point of view, whether we have to connect a switch at the access layer or the distribution layer or the core layer or whatever layer, the switches that we have these Catalyst 9000 series switches. Very popular platform, Catalyst 9000 series switches. A Catalyst 9200 series switches is quite equivalent to those 2950, 2960 series switches. The 9300 series switches are pretty much equivalent to those 3000, 3550, 3560, 3738, those 9500 series switches, 9600 series switches. These are, like 45, like 47, those series switches, 67, 6000 series switches that we used to have. So you don't see those pure. For example, you don't see in your production environment, or you don't see these 2950 or 2960 series switches nowadays being sold by Cisco. 9200 series switch. This, even if you go for a very low end switch, which is this 9200 series switch, if you go for this, even if you go for a very low end switch such as 9200 series switch, and if you go to the data sheet, you will notice that here in this particular switch platform, you will actually have the routing function. If you go to the software, first of all, these switches run on a flavor of iOS called iOS XE. The traditional routers and switches that you might have worked on so far, they work on iOS. There is a flavor of iOS called iOS XE, which is a different type of software. It like from the command point of view, it looks exactly similar, but it works in a little bit different way. The way it is deployed on the routers, on the switches nowadays, it's quite different than a traditional iOS. So iOS XE is different than iOS in a lot of way. The main point is that if you go through the documentation, if you go through this documentation, you will notice that these switches, even if you go for a basic 9200 series switches, you will definitely see some routing functions. If I go to the, where is that? If I search routing, you see, if I just search routing, you can see that even though this 9200 series switch can perform like static routing, RIP version 1, version 2, RIP for IPv6, OSPF, maybe EIGRP as well, routing functions are there. So in fact, it also supports like multicast routing protocols such as PIM and all. So we can't really say that it is a layer 2 switch. So saying this was a little bit incorrect, like saying this was a little bit incorrect because it's not completely as a 2950, 2960 series switch. Even though if you go for like a very small, a very low end like 9200 series switch platform, it is going to give you the routing function. So in a way, like you will not find a switch that is purely going to work on the layer 2 of the OSI model. Some basic routing functionalities will still be there, even if you go for a very low end switch such as 9200 series switch. If you go for 9300 series switch, then you will get more and more functionality. You go for 9400 series switch, 9500 series switch, you will get more and more functionalities. So if you go for Catalyst 1200 series switches or 1300 series switches, these are like again affordable low end basically switches. You can go for like these switches. You can read to the data sheet if you want to, to find out the support of routing and all that thing. What things you can do, what things you can't do. You can see that you can manage it from some centralized dashboard and all. From a production point of view, from your enterprise network point of view, even if you go for a low end switch such as like a 9200 series switch, it is going to come with the routing functionality. So this line between this difference between the layer 2 and layer 3 switch is nowadays like pretty much to none. Like nowadays the switches that we have, whether we have purchased the 92, 93, 94, whatever switch we have purchased to install in our production environment, it is going to have some routing functionalities. And I'm specifically talking about from the enterprise network point of view, not from like home network point of view, because you can say that we can purchase an unmanaged switch. We might not run any routing protocol, and so that's not going to be like, that's not going to work here. We are talking specifically from the enterprise network point of view. So if you purchase a layer 2 switch, or if you purchase a Catalyst 92, 93, whatever switch you purchase, any Catalyst 9000 series switch that you purchase, it is going to come with some level of routing functionality as well. These are very much in fashion nowadays. Catalyst 9000 series switches are very much in fashion. However, you can still see the old Catalyst 3650, 3850 series switches, not 3750. You still see 3650, 3850 series switches in the modern environment, 65, some 6000 series switches, some 45, 4700 series switches. You still see those switches in a production environment. But if you have to build a network from the scratch, if you are talking about a greenfield deployment, greenfield basically means we are talking about a deployment where we have to configure things from the very scratch. We have to purchase the switches, connect it, configure it. Then you are going to purchase and install a Catalyst 9000 series switch specifically. But not to say that you're not going to have these old switch platforms. You can still have in your production environment the 3750, 3760, 3850 and all that. You can still have those switches, but almost everything is going to be like the routing capable. So pure layer 2 switches, you might not see in your production. Yes, let me know.
Yeah, Surendra sir. So this one Catalyst 9K switches and these Nexus 9K switches, these are same or
no? These are different. These are different.
Oh, okay.
These are different
switches. What is the difference? I mean, in between then, because both are 9K, right?
The Catalyst 9000 and the Nexus 9000. If you notice, like if you go to the product documentation, this is specifically the Catalyst 9000 series switches, and if you go for that Nexus series switches here, like in the data center switches here, the Nexus 9000 series switches. So from the look and feel point of view, these are a different type of switches. They work on different technology, more like I would say. So these are not exactly the same. These are some different switches. The N, they start from N, N91, 92. Why we this the L2 switches basically? Because actually, to be honest, like no one is willing to do switching anymore. Like, most of the things are moving towards the routing. You will understand why. But even if, like I said, like even if you go for a basic 9200 series switch, you will get some routing functionality. Why? Because there is a thing called nowadays in the market, there is a thing called software-defined network, where the engineer is not willing to configure like each and every device like one by one manually. They are going to use some sort of software, and from that software, what they are going to do, they are going to manage, they are going to configure, they are going to control all these switches, routers, and all these devices that we have, such as access point and all. Controller-based networking is more and more in fashion nowadays. And controller-based networking, or this software-defined networking, where a piece of software is supposed to configure all these devices, such as routers and switches, from a centralized place. Engineer doesn't need to interact with those thousands of switches, thousands of devices, hundreds of switches, hundreds of devices. Engineer can just interact with the software. Engineer can define its intent, what they want to do on that software, and that software is basically responsible to push. The software is basically responsible to convert that intent into the configuration and push the configuration on all the routers and switches or whatever. So this thing called software-defined networking is very much in fashion nowadays. And software-defined approach to manage the campus local area network is what they refer to as SD-LAN. Software-defined approach to manage the campus local area network. If you have, let's say, for example, a campus LAN, you don't want to interact with all these devices like one by one. What you want to basically manage all these devices, all these campus area network from a centralized controller. The software-defined approach to manage the campus local area network is what they refer to as SD-LAN. Cisco calls it like SD access. Other vendors, they call it SD-LAN, software-defined LAN, which makes more sense. But anyway, Cisco calls it basically like SD access or SDA. Software-defined approach to manage the campus local area network is what they refer to as SDA. And one of the recommended design, if you want to implement the SDA in your environment, one of the recommended design is that everything has to be routing, not switching. You will study it later on. We will talk about that in design section of our content. But one of the recommended design when we try to implement the SDA, the software-defined access, one of the recommended design is basically a routed access layer. We'll talk about it. Not the STP-based access layer. The routed access layer, where all the switches, all the way up to the access layer, it is routing rather than switching. So no need of like any STP, VTP, trunk, VLAN, DTP, HSRP, VRRP, no need of any such protocol. Reason why they have removed the dedicated certification exam of Cisco of the switching, because things are moving towards the software-defined networking. And when we talk about the software-defined approach to manage the campus local area network, which is what they refer to as the SDA, one of the recommended design in the SDA is to follow that routed access layer. And in the routed access layer, everything is routing. There's no switching involved. From the switching point of view, what you need to know, what is VLAN? Because this user is going to be part of some VLAN. The VLAN trunks maybe, or maybe some ether channel. But apart from that, you don't need a whole lot of like switching knowledge for that thing. And since it's recommended to have a routed access layer, even though the switches that we connect at the access layer, they have to have the capability to participate in the routing actually. And in order to make these switches participate in the routing, some routing protocol needs to run. So we can't connect a pure layer 2 switch basically there. So even if you go for a very basic Catalyst 9200 series switch, it will come with some functionality of the routing, so that when we connect that switch at the access layer, it can participate in the routing, can build the EIGRPO script neighborship, can exchange the route basically, so that we can create the routed access layer. So pure layer 2 switch, you might not see, especially when we talk about a fresh deployment, when we talk about a greenfield deployment, a pure layer 2 switch, are you going to connect? Maybe like when we have to extend our network, maybe you are going to connect some unmanaged switch from here, or some old switch platform from here. But from a fresh deployment point of view, if you follow the access distribution and core, even if you go for a basic switch, you will get the routing capabilities, because either today or tomorrow, you will go for the software-defined network. So all these switches, all these Catalyst 9000 series switches, they are capable of being managed from a centralized controller. That is what we refer to as the DNA center. DNA center, also known as the Catalyst Center nowadays. They have renamed the DNA center to the Catalyst Center, which will give you the software-defined capabilities in the campus area. Most of the switches that we use in the network, they are routing capable. Why they are routing capable? Because of this thing called software-defined network. Why we don't study like switching in that much detail as we used to do like earlier? Because it might not be relevant in near future. Not at least that much as it used to be. Why they just wanted to know about the VLAN, trunks, and some basic like ether channel technology, because that's the only thing that will make sense. Because when everything goes to the L3, you might not see switching being used in between the access and distribution like you have seen in the past, or like you might be seeing right now as well. But maybe in near future, when we go for the software-defined approach, maybe not. Like you will not see that switching being used that much. So they don't have that detailed discussion of the switching now in the country. These switches, by the way, why we use these switches? Because these switches are also compatible with the DNS center actually. These switches are also compatible with the Catalyst center actually. These switches can also be managed from a centralized controller actually. Although these switches are very old switches, like 3850, if you talk about these, this is a very old switch. 45, 46 or Catalyst 6500 series switches, if you talk about, these are like very old switches. But at the time when Cisco manufactured those switches, they added a special chip, the ASIC, application specific integrated circuit. A dedicated chip is there in all the switches, that is responsible to make all the decision. When Cisco created those Catalyst 3000, those old switch platforms, they introduced a special type of switch, which is what they refer to as they used to refer to as UADP. You will study this in SDA later on, but they call it like UADP, Unified Access Data Plane, a special chip that they have in all the Catalyst 9000 series switches nowadays. And the earlier version of this UADP chip is also present in those 3850, 3650 series switches actually. And the best thing about this switch, this chip, is that it's programmable. Meaning to say that Cisco just can push a firmware upgrade and they can enable the SDN capabilities on these 3650, 3850 series switches, so that you don't need to purchase a complete new switch for your production environment just because you wanted to do the SDN, just because you wanted to implement the software-defined networking. You can just do the firmware upgrade, and the SDN capabilities are going to be enabled on that UADP chip. Some additional protocol basically will be enabled onto that chip, so that you can use those switches for the software-defined access environment. We can't say the same for 3750. In the 3750, we don't have that UADP chip. So 3750 chip, 3750 series switch is not actually compatible with the DNS center. It is not compatible with the software-defined networking. You might not see the use of 3750 in your production environment that often as compared to the 3850 or 3650. They have moved, by the way, from the UADP to a new chip. We don't need to talk about it because we are going to cover these things in the SDA later on. A Silicon One, there is a new chip that they have introduced which offers much more throughput, much more bandwidth, much more higher capability to forward the data, referred to as Silicon One. So now we have like UADP based chip, we have Silicon One based chip, we have some normal ASIC based chip. So switches, we have different types of switches, but in a production environment, it's all going to be Catalyst 9000. All 92, 93, 94, 95, 96, 3650, 3850, these are still being used because they are compatible with the centralized controllers such as Catalyst Center, also known as the DNS Center. When Cisco created these switches, they added that earlier version of the UADP, which makes it, then Cisco just sent a firmware upgrade to enable the SDN capabilities on these switches. So you will still see these switches in your production environment, even if you talk about the software-defined networking. But the other switches such as 2950, 2960, 3750, 3760, you will not see those switches basically. One of the reasons is that they are not compatible with the DNS center or Catalyst center. So later on, if you plan to implement the SDN capabilities, you will not be able to. Same thing for 45, 65, 68. So these are some common switch platforms that we use in our production environment now. And they run on iOS XE, by the way, a flavor of iOS that is much more better as compared to traditional iOS. Maybe we can spend some time learning about this as well. But iOS XE is what we see nowadays in the routers and switches. A flavor of iOS that runs on the routers and switches in our current production environment, at least from the enterprise environment point of view. Using these switches, now we are going to build our campus local area network, campus area network. We are going to build either 2-tier, 3-tier, or whatever, STP-based routed access layer, whatever these are. So we are going to build our campus area network based on these basically switch platforms, right? We'll talk more about it. Like, for example, what type of ports we have on these switches. This was just the introduction. What is switching? What is switching? What type of switches we have? This was just the introduction part. We'll talk more about it. We'll talk about like the ports, the interfaces that we have on the switches, how to take the access of these switches, what are the methods to take the access of these switches, and all. We will definitely talk about it later on. in our content tomorrow. Once it is done, then we will talk about our like enterprise network architecture, right? So for today, you can just revisit the recording, revise things from the recording. You can just discuss. You can just go through the recording and cover these 2 slides, and more we'll talk about from here. When we talk about switch ports, when we talk about the ports of the catalyst switch, whether we are talking about a layer 2 switch or we're talking about a layer 3 or multi-layer switch, when we talk about the ports that we have on these physical switches, actually on these switches 92, 93, 94, whatever switches we are using in our environment. So there are going to be ports that we can actually see, that are physical ports, I would say, interfaces, physical interfaces that you see actually on these devices, such as these gigabit interfaces that you have, fast Ethernet interfaces that we have. You might have some additional interfaces to plug in something called an SFP, small form factor pluggable, where we can insert maybe a fiber module or maybe a copper module. We can connect a fiber cable or maybe some high speed uplink towards the other switches and all. So these are like the physical interfaces, physical ports. Ports and interfaces, by the way, in terms of like routers and switches, when we talk about ports or when we talk about interfaces, they seem to represent like the same thing actually. That's why when we talk about like routing, when we talk about switching, typically we don't differentiate between the ports and interfaces. We use these terms port and interfaces like interchangeably. We use this terminology like port, we use this terminology interfaces interchangeably. But in some technologies, such as later on someday, like when you study, like for example, wireless, you will notice that the term port and interfaces, they mean complete 2 different things actually. But here with context to like in context of our routing and switching, the term port and the term interfaces, it mostly represents the same thing, same exact thing. Like the physical ports, physical interfaces that we can see, where we can plug in the devices, plug in the routers, plug in the end users, servers, whatever. So we use the term port and interfaces like interchangeably, at least in routing, switching, maybe also in firewall or other technologies. But in some places, such as like wireless, you will notice that the term port and interfaces, they represent 2 different things. So whenever like you study wireless, you will get to know that. But in context of like our switching, the ports and interfaces, the term port, the term switch port interfaces, they generally are going to represent exactly the same thing. So we generally use these terms interchangeably. We use these terms like interchangeably. Now, these ports that we have on our catalyst switches, catalyst layer 2 switches, layer 3 switches, maybe like multi-layer switches like 45, 65 or some other 90, 95, 96, like these switches. These physical interfaces that we have, these physical ports that we have, these can be configured to operate as a switch port, or they can be operated as a routed port. These physical interfaces that you see, when we talk about like catalyst layer 2 switches, layer 3 switches, multi-layer switches, for example, these physical interfaces that you see, these physical interfaces can be configured to operate as a switch port, or they can be configured to operate as a routed port. Switch port basically means a port where that forwards the data based on like MAC address. A switch port basically is a layer 2 port, which works based on like the MAC address, which works based on like the VLAN. The layer 2 port must be configured with some VLAN membership. If we have not configured the VLAN membership onto that layer 2 switch port, the port will not be functional actually. So these physical interfaces that you see, we can configure these physical interfaces to act as a layer 2 switch port, where we are going to assign some VLAN membership, onto that switch port. And based on what VLAN membership is assigned, the switch port is going to work based on the same. Like if the port is assigned the VLAN membership of VLAN 10, then it will send and receive the data for VLAN 10 only. If it is assigned the VLAN membership of VLAN 20, then it will send and receive the data for VLAN 20 only, or maybe something called a trunk, whatever that means. But the point is that the layer 2 ports that we have, or switch ports that we have, layer 2 switch ports that we have, they always work on the VLANs. They are layer 2 ports. They do their packet forwarding, they do their data forwarding based on the layer 2 address or the MAC address. we can't configure the IP address on those layer 2 ports. If a port is operating as a switch port, if a port is operating as a layer 2 port, the only thing that you will see there is a VLAN membership. It will learn the MAC address, perform the packet forwarding, perform the data forwarding based on the MAC address and all. Like a few properties will be there, but we will not be able to configure some IP address on those particular ports. Or you can change those ports. Basically, you can change those physical ports like these physical interfaces that we have. You can change these ports to make them operate as a layer 3 ports or routed ports. When we configure these ports as the routed port, when we configure these ports as the routed port, they will be able to perform the packet forwarding based on the IP address. Basically, they will behave as if the port is a routing port, a routed port. They will behave like a port that we have on a router, typically where we can configure an IP address and all. So if you configure the port to operate as a layer 3 port or the routed port, we can directly configure the IP address onto that port. And then based on that, based on the IP address and all, the device will be able to perform the packet forwarding similarly like a router does. And we can change the port behavior from the layer 2 port to the layer 3 port or from the switch port to the routed port by using a single command. There is just one command. You can run that command and you can change. When you run that command, you can change the behavior. You can change the way. You can change the behavior. You can change the mode, the operating mode of that switch port, either to be a layer 2 port or a layer 3 port, a switch port or a routed port, a port that forwards the packet based on the MAC, or port that forwards the packet based on the IP. We can do that by just one single command. We'll talk about it. But these are the physical port. This is about the physical port. The physical port that we have on that and that physical port that we have on the switch platform can work in either of these two. You can't configure a port like obviously in both of the mode. Either it will work as the switch port or it will work as the routed port. You can do like if you have a 48 port switch, for example, then first like 24 ports for the switching, 24 ports for the routing, those kind of things you can do as per the requirement, but you can't configure the port to operate in both of the modes like L2 and L3, that the switch port and routed port at the same time. Yeah, that's not good. Now, apart from that, like apart from these, the physical ports that we have, where we can connect the devices like physically, like the switches, like the routers, like the end users, like the servers and all. We can connect like our physical devices on here. Similarly, we have some on these devices, we have some logical interfaces, some virtual interfaces as well. On these switches, we also have like, we can also create some virtual interfaces that you will not be able to see. You won't be able to see those interfaces. You can't physically connect. You can't connect like any device onto those interfaces. They will behave like a virtual interface. They will behave like a logical interface. They will behave like a virtual interface where you can't actually connect like any physical device such as router, such as switch, such as PC or any end user or anything like that. You will not be able to connect any physical device. Virtual interfaces such as, or some logical interfaces such as, we can create something called a loopback interface. Loopback interface is like an interface configured using some commands. A loopback interface is a logical interface that we create on the routers, on the switches for various purposes. So but nothing is physical about the loopback interface. Like we can't connect physically, we cannot connect any device physically on that loopback interface. It's just a logical, it's just a more like a virtual interface. We can create the interfaces such as port channel. Maybe like if you already have gone through the things about the ether channel, then you must know that when we bundle, it is possible that we can bundle multiple physical interfaces. We can bundle multiple physical interfaces of the switch to act as a single logical interface. And that single logical interface, after the link bundling, is known as the port channel interface. So it's nothing like physical. You don't see that port channel interface like physically. It's a result of a link bundling. So we have that port channel interface. It can be either layer 2 or layer 3, which will be discussed in the ether channel section later on. But port channel interface is also a virtual interface, a logical interface, a virtual interface. Another type of interface that we might have, another type of like a logical or a virtual interface that we might have on the switch platform is known as I believe you already know about it. It is known as switch virtual interface or SVI. SVI or switch virtual interface is it's a logical interface. It is basically a logical interface that we have. It is basically a logical interface that we have where you can't physically connect like any device actually. You cannot physically connect like any device onto that particular interface. It's a logical interface also. This is also, by the way, a logical interface, SVI. It is in fact named as switch virtual interface. It is named as switch virtual interface or SVI. We'll see the use case of each of them one by one. But SVI or switch virtual interface. So, like what I'm trying to say is that we have some physical interfaces on the devices. We have some logical interfaces on the devices. All have their own purpose. All have their own some requirements, some purposes. Why would we create a port channel interface? Why would we create like a loopback interface? Why would we create like some SVI and all? We'll talk about it one by one. But like all of these interfaces, they have some certain rules, so some certain tasks. So we have different types of ports. We have different types of ports on the switch. If you talk about a layer 2 switch, if you talk about a layer 2 switch, such as a 2950, such as 2960, if you talk about a layer 2 switch, all the ports of the layer 2 switch, they will always be like layer 2 ports. You can't convert them into the layer 3 port. These will always be like switch port. They will never be like a routed port. The old switch platforms such as 2950, such as 2960, the ports that we have on those switches, they act at layer 2. They basically are layer 2 ports. They basically are the switching ports. They basically are the switch ports. We cannot configure the IP address on those ports. Those ports will work based on the VLAN membership, and so they will work based on the VLAN membership, and so they will not basically they cannot be configured with the IP address directly. We can't really do that. So those ports are pretty much like the layer 2 ports. Since we do not have, by the way, layer 2 devices, layer 2 switches in the software such as ENCOR, I would recommend that you maybe like, if you want to test these things, you can download and install this software called Cisco Packet Tracer. I hope you know about the Cisco Packet Tracer. Very popular software for trading in CCNA and all. So since we don't have like the layer 2, I would like to make this very clear. We do not have like a layer 2 switch image for the virtualized environment such as ENCOR. You don't have that, by the way. I will clear this even more. So when you download and install the software such as ENCOR, where you can practice the things in a virtualized environment. So let's say, for example, this is the ENCOR, by the way, ENCOR platform, ENCOR or PNet Lab or whatever, platform that you might be using to practice the things in a virtualized environment. If you add this node, and here if you see like we have, where is that, our IUL, iOS on Linux. So here you see that in the image name, it's mentioned as L2. So L2 image, L3 image. L3 simply means router and L2 simply means switching. L2 means switch, L3 means router. L2 does not mean, by the way, L2 doesn't mean that it's a L2 switch image. L2 basically means it's a switch image. It's not an L2 switch image. Basically, it's just a switch image. So like if you choose this image and you think that it's a layer 2 switch, nah, it's just a switch. It's more like a layer 3 switch. It's more like a layer 3 switch rather than a layer 2 switch. It's more like a layer 3 switch actually. Okay, so it's not a L2 switch, by the way. I will prove it later on, but it's not a layer 2 switch. It's just L2 means that it's a switching image, and L3 basically means it's a routing image. So basically it's a router and it's a switch. What type of switch? Is it an L2 switch? Nah, it's not an L2 switch. Right. So understand that very clearly, that just because it's written as L2 and L3, it doesn't mean it's an L2 switch or it's an L3 switch. No, it's not. So if you want to see a proper like a layer 2 port, what we have to do, you have to have some old switch platforms such as 2950, 2960. Either you can get those like hardware. Otherwise, you can download and install this, old tool that you might already be familiar with called Cisco Packet Tracer. And if you go under the switches, you will have the 2960 switch image, and you will also have the 2950 switch image. So you have 2950, you have 2960. You have both of the switches, by the way. You have both of the switches, by the way, in this Cisco Packet Tracer software. You have a 2950 switch. This is 2950 switch, and this is a 2960 switch. This is a proper Catalyst 2950. You're already be familiar with these things, like, it's nothing new actually. So it's already it's a layer 2. It's a 2950 series switch, and this is basically a 2960 series switch. It is a 24 ports. Yeah, it's a 24 ports, and that is what? That is also 24 ports. So 24 port switch. So now if you connect, let's say, for example, a PC here. If I take a PC here, and if I connect, like, let's say, for example, two PCs here, and I connect it via the cable, I connect it via the fast Ethernet 0x1, and I connect it like via the fast Ethernet 0x1 or 0x2, for example, here. So this is 0x1, this is 0x2. These ports that we have, these ports are, by the way, the layer 2 ports. I will connect one more switch. I will connect one more PC, by the way. Let me connect one more PC here. I will connect one more PC here. This is 0x3. So this is 0x1, this is 0x2, and this is 0x3. We have like, I have connected this three PCs with this layer 2 switch. And I don't want to wait like a lot. So I can just directly do the fast forward in packet tracer. So the time will simulate a little bit faster. If you remember, like in the switches, we have the protocol like STP, listening state, learning state, then forwarding state. So it takes approximately like 30 seconds for these ports to come up. You might be aware of that. So once that's done, ultimately these ports are up. And if you take the access of this switch, by the way, if you take the access of this switch, there is a console. There is a console port, by the way. Here there is a console port. You can connect a console cable here, and you can take the access of that switch, just like you take the access of a router, you take the access of a firewall. There is a console port from where you can connect your PC terminal using a console cable, and you can take the access of the switch, CCNA level stuff. In packet tracer, however, I can directly jump to the CLI. I can directly go to the CLI and I can take the access here. Just like if you go on the ENG and you just click on the device and the console opens. But of course, in the real world, it's not the same thing. You can't in real world, you can't just click on the device and console will open, of course. So in the real world, you have to follow the approach, connect the console cable, open some software sites such as PuTTY, Security RT, and then access it from there. And you see here, you check it here, that the interface fast Ethernet, first of all, we call it interface. First of all, like we call it an interface. So interface and port, they are being used synonymously. Second, if you check here, like show interface is fast Ethernet 0x1. If you check here, to interface is fast Ethernet 0x1 switch port. If you use the command show interface is fast Ethernet 0x1 switch port and press enter, you will see here show interface is fast Ethernet 0x1 switch port. You can see here that FS 0x1 switch port is enabled. If the switch port is enabled, it means that it's a layer 2 port. And if it is a layer 2 port, it must be part of some VLAN. And I hope you remember that the default VLAN on the Catalyst switches is basically 1. By default, all the ports are part of the VLAN 1. By default, all the ports are part of the VLAN 1. This command will display, this command will show you whether the port is a layer 2 port or a layer 3 port. If you see the switch port enabled, means that it's a layer 2 port. If you see the switch port disabled, it means it's a layer 3 port. If it's a layer 2 port, it must be configured with some VLAN membership, which is by default 1. And if it's a layer 3 port, then we have to configure some IP address onto that port so that it can do the packet forwarding. It can forward the data based on the CA. Other things you don't need to worry about. Just focus on whatever we are discussing. That if you see the switch port enabled, that means it's a layer 2 port. And if it is a layer 2 port, then some VLAN membership has to be there. And you already know that on Catalyst switches, the default VLAN membership is, by the way, 1. And you can't convert it. Configure terminal, interface FA0x1. And if you use the command no switch port, you can't run that command no switch port. You cannot convert. You can't convert that particular port into a layer 3 port. That means the only option that we have here is maybe to configure some VLAN membership, maximum to maximum, like switch port access VLAN this, access VLAN that, or whatever. But we can't really convert this port to act as a layer 3 port so that we can configure an IP address on that. You can't really do that. So this is basically a layer 2. This is a layer 2. On the other hand, if you had a layer 3 switch, such as in the packet tracer, either in the packet tracer or maybe in the ENG, whatever, you can have a layer 3 switch, by the way. If you go to the network devices, switches, And if we take like 36503560, this is by the way a layer 3 switch. This is a layer 3 switch that we have here, and we are going to connect like for example, a few PCs here as well, and I'm going to connect it via the wire. That is again gigabit 1 by 0 by 1, gigabit 1 by 0 by 2, and gigabit 1 by 0 by 3. And this is a Catalyst 3650 series switch, by the way. This is a Catalyst 3650 series switch. This is the front panel and this is the back panel. This Catalyst 3650 series switch requires the power supply. So like we have to drag and drop the power. Power basically here. Once we add the power, then only that switch will, we have to connect the AC power supply here. Then only the switch will boot up. And once the switch boots up, again, the STP and all that thing will run. Will take at least 30 seconds for the port to go into the forwarding state. I really don't want to wait that much. So I'm going to click on fast forward time so that the ports immediately go into the forwarding state. In packet tracer, we can simulate the time faster. Can't do that in real world, but can't do that in ENG also. So anyway, here basically these ports that we have on a Catalyst layer 3 switch, or maybe a multi-layer switch, these ports that we have, for example, like enable, configure terminal, host name, switch number 2, and if you use the command show interfaces gigabit 1 by 0 by 1 switch port, you can see show interfaces gigabit 1 by 0 by 1 switch port. You can see here that by default these ports are also layer 2 ports. By default these ports are also layer 2 ports. So show interfaces gigabit 1 by 0 by 1 switch port. By default these ports are also layer 2 ports. And if it is a layer 2 port, then it must be part of some VLAN. The VLAN is basically 1. That is the default VLAN membership. But since it's a layer 3 switch, I do have the option to go under the interface. What is that? Interface gigabit Ethernet 1 by 0 by 1, and I can use the command no switch. No switch port command will convert that port from the layer 2 to layer 3 port, and now I can configure the IP address directly, such as 192.168.10.1, which I cannot do. I cannot do on a layer 2 switch. We cannot configure like any IP address on a layer 2 switch port. We can't do that. We cannot configure the IP on a switch port. We can configure an IP on the routed port, and in order to make the port act as the routed port, we have to run the command no switch port. And you can see show interfaces gigabit 1 by 0 by 1 switch port and enter. Now you can see that the switch port is disabled. If the switch port is disabled, that means it is a routed port. It will not be displayed in the show VLAN brief. That port will not be displayed in the show VLAN brief output. That port will not be displayed here because it's no longer a switching port. It has become now a routed port. You can confirm show IP interface brief, and you can confirm that you have configured some IP address there. You can confirm show run. You can confirm that by using the command no switch port, you converted the port as a routed port, and you are able to configure the IP address on there. So on the layer 2 switches, all the ports will be the switch port. But on the layer 3 switches or maybe the multi-layer switches, we can have the physical port, that physical port operate as the switch port, or we can make that port operate as the routed port. Switch port means layer 2, routed port basically means layer 3. It is, if the port is layer 2, it must be configured with some VLAN membership, and if the port is layer 3, it must be configured with some IP. Basic, like this is the very basic of the physical port. Like the physical port we can configure as per the requirement to act as a layer 2 or layer 3. Maybe for example this is a switch that is connected to a router, and it is also connected to some LAN users. So what I can do, I can configure, for example, this port as a routed port. I can configure this port as a layer 3 port. I can configure some IP here. This is already a layer 3 port. Some IP is there. So IP address is configured. Now I can configure some EIGRP, OSPF, and all that thing, routing protocol. Since it's a layer 3 switch, no, it supports routing. I can configure EIGRP or maybe OSPF to exchange the routes and everything so that the ping trace works and all that thing. So based on the requirement, you might or might not want to convert the port from the layer 2 to layer 3 and vice versa. However, understand that anytime you change the port from layer 2 to layer 3, layer 3 to layer 2, the configurations on that port are erased. For example, configure terminal, interface gig 1 by 0 by 1, description, it's a port towards user, whatever, and I have configured some IP address there. I have used the command no switch port, and I have configured some IP address such as 192.168.10.1. I have configured some IP address there. Now, if I try to convert this port back into the layer 2 port by using the command interface gig 1 by 0 by 1, and I use the command switch port. So to convert the port back into the layer 2 port, you can see here, show run, you can see here that the configuration of that port is gone. Even if you convert it again, like interface gigabit 1 by 0 by 1, and if you do it again, like no switch port, you can see no switch port and check it again, the configuration will definitely not be there. So make sure whenever you convert the port from layer 2 to layer 3, layer 3 to layer 2, always take some backup, always run the command show run interface gig 1 by 1, always run those commands so that you can see what configurations are there. Maybe you can note down those configuration and then do the conversion. Otherwise, whatever configuration you did, they will be wiped. So you might not know what IP was there, you might not know what VLAN membership was there. So you have to be careful when converting the port from the layer 2 to layer and vice versa. And you can check this in the ENG also. Like, it's not like it's only in packet tracer. So I have opened ENG. I can click on the node. I can go on that IOL. Where is that? IOL. And I'm going to choose this image. This image name is like Linux L2 Advanced Enterprise High Iron 2019 0423. This is most probably the most stable image that we have for the switching, where we can practice like almost like everything regarding the switching. This is the most stable image that I could find. They also launched later on some iOS XE based images as well, but some functionalities, it doesn't work properly in these images, so I don't use it. I still stick to this 2019 0423, that image basically. This is pretty much like very stable image that we have for the switching. So I will choose this image. I'm going to name it like SW. I'm going to add like maybe 4, 5, 4, or maybe 5, for example, like nodes. I'm going to change the symbol to match it with a switch, by the way. So otherwise it will show it like a router. So I will change the symbol. Maybe if you want to have like more switch ports, by default, the switch will come with 4 ports. So if you want like more than 4 ports, then 2 port groups. 2 port groups basically means 8 port. 3 port groups basically means like 12 ports and so on. So by default, like 4 ports are there in this switch. We can increase the ports as per the requirement. At the moment, I don't need it, so I'm not going to change. Right, so this is switch 1, switch 2, switch 3, switch 4, switch 5. I'm going to just take one switch. Like, this is the one switch that I'm going to use. And this switch, by the way, is a layer 3 switch. Actually, it's not a layer 2 switch. Just because we are using that L2 image name, it's not L2. It's, by the way, L2. I will prove it. And for the end user, I'm going to choose, for the end users, I can use the virtual PCs, VPCS. I can simply choose the VPCS. I can simply choose these PCs, these virtual PCs. I can choose maybe like 3 or 4 like virtual PCs as per the requirement, 4 maybe. These are just basic PCs, so maybe one here, maybe like one here, maybe like one here, and one here maybe. So I'm going to use like some virtual PCs. I don't need like to do a lot of things. So I'm just going to choose this virtual PC and I'm going to connect this here, 0 by 0. Okay. I'm going to connect it basically here. That is 0 by 1. I'm going to connect it basically here. That is 0 by 2. And I'm going to connect. We are not talking about design and so, right? So don't worry about the design and all that thing. Just understand the rules of the ports. That is it, right? And just power on these devices. Like, I'm going to power on these devices. And you can see that just like the packet tracer, exactly similar to as the packet tracer in the software such as ENG or PNet, basically, when you take these switches, when you use these switch images, by the way, these are, by the way, the layer 3 switches. See, enable, configure terminal, host name, switch 1, and you can see show interfaces, Ethernet 0 by 0 switch port, show interfaces, Ethernet 0 by 0 switch port. You can see that the switch port is enabled. That's why we are getting this pretty much output, like a lot of output here. Show interfaces, switch port. You can see that a lot of output is here. Switch port is enabled, by the way. So it's a layer 2 port. And you can see that it's not really a layer 2 switch, because I can go on the interface and I can directly use the command no switch port. and I can then configure whatever IP address and mask that I want to configure. I can configure it right away. So it's actually not a layer 2 switch. Just because the name says so, it's not a layer 2. It's by the way a layer 3 switch. You can see that here I was able to configure show run interface Ethernet 0x0. You can see that I was able to configure the IP address on the port by using the command no switch. This functionality of changing the port from L2 to L3, L3 to L2 will only be available on layer 3 or multi-layer switches. You will not get this functionality on the layer 2 switch. Of course, L2 switch will work on the VLAN MAC address only. It can't do the packet forwarding based on the IP. We can't convert the port of the L2 switch as an L3 port and configure the IP address on it. We can't do that. That's what is mentioned here in the document. A switch port on the Catalyst layer 3 switch can be configured to operate as a layer 2 port, works on the VLAN membership, layer 3 ports, configured some IP address, L3 to L2, no switch port, so these commands are only applicable on these commands are not applicable on the layer 2 switches. Okay, fine. You can read if you want to, but it's the same thing that we have covered. To verify whether the port is a layer 2 port or layer 3 port, show interfaces and switch port command you can use. If the switch port is enabled, then it's layer 2. If the switch port is disabled, then it's a layer 3. The question is how one command has the power to change the port from the L2 to L3. Remember that L2 ports, they have a different property, L3 ports have a different property. How that one single command actually is able to change the property of the physical port from the L2 to L3, L3 to L2. How is that even possible? Basically, what is happening in the background? What is going on in the background when we use that command switch port, no switch port? What is basically going on in the background? What is happening in the background? Second, what if I want to configure the IP address on the switch? On a layer 2 switch, I can configure the IP address on the layer 3 switch. I can just convert this port into a layer 3 port by the command no switch port, and I can configure an IP address onto this switch. Why? For the management purpose, maybe. But how am I going to do that? How am I going to telnet? How am I going to do SSH onto that layer 2 switch, by the way? Two questions. First question that we have here is that what is going on in the backend? What is happening in the backend when we convert the port from the L2 to L3, L3 to L2? What is going on in the backend? First of all. Second, since on the layer 2 switches, we cannot convert the L2 ports into L3 on the layer 3 switch, on the layer 2 switches, how am I going to configure the IP address then? Why would I want to configure an IP address on a layer 2 switch? So that I can do telnet, I can do SSH, I can do the management related things basically on there. How can I do that then? One by one. First of all, what happens in the backend? Actually, what happens in the backend? If you're talking about these Catalyst like old switch platforms, if you're talking about those old switch platforms such as 3550, 3750, those old switch platforms, if you're talking about like iOS, when we use the command no switch port, basically what happens in the background? Let's say I went on the interface. On the interface like gig or like 1x0x1 or whatever, and I use the command no switch port. What happens in the background actually is that this switch is going to create in the backend, it is going to create an extended VLAN. It is going to create in the background, the switch is going to reserve a VLAN from the extended range. Remember, 1 to 1005, this is the normal range VLAN. And from 1006 to 4094, this is extended range VLAN. So the switch is going to create a VLAN from this range, 1006 to 4094. The switch is going to create a VLAN from that range, either in ascending order or descending order. By default is ascending order. That means it is going to create the VLAN 1006. In the backend, the switch will reserve a VLAN from that extended range. The extended range VLAN is from 1006 to 4094. That means the switch can create any VLAN from this range. However, it goes in either ascending order or descending order based on how we have configured the switch to do so. By default, it's ascending. So it will create the VLAN like 1006. And it will map that port like gigabit 1x0x1. It will configure that port into that VLAN logically. It will not be shown in the configuration. It will not be displayed. It will not be shown in the configuration. but logically in the backend, the switch is going to map that physical basically interface with that particular external VLAN that has created in the backend. It will bind that physical port with the VLAN. Logically, you will not see that anywhere in the configuration, but it will happen in the back. And it will disable all the layer 2 protocols like onto that port, such as STP, VTP, DTP. So like STP messages out of that port, DTP, VTP messages out of that ports will now not pass. And then let's say on the interface gig 1 by 0 by 1, if now I configure an IP address, what it will do, it will create logically, it will create virtual interface. It will create a switch virtual interface. It will create a virtual interface for that VLAN called an SVI for VLAN 1006. And whatever commands such as IP address, IP OSPF, whatever commands we configure regarding IP, those commands will logically run on that SVI, on that layer 3 interface for the VLAN. What is an SVI? SVI basically is a layer 3 interface for a VLAN. SVI is basically a layer 3 interface for the VLAN. A layer 3 interface for the VLAN is what we refer to as an SVI, as a switch virtual interface or SVI. So it will create an SVI for the VLAN 1006, and all the L3 commands that we are running, such as like IP address, IP OSPF, access list, whatever commands you run, actually on the physical interface, they are logically being run on that particular SVI, on that particular switch virtual interface. Logically assume an SVI for that external VLAN, and all the layer 3 commands that we run on that physical interface after using that no switch port command will actually logically run on that particular switch virtual interface. And we can check it. It's not like we can go on this particular switch here. We can go on this switch and you can check it. When we use the command no switch port and I configure the IP address there, I can check it. Command is show VLAN internal users. So if I have, let's say, for example, 4 ports, if I have like 4 ports, interface range 0 by 0, 1, 2, 3, and on all the ports, if I use the command no switch port, so what will happen? It will create like total 4 VLANs from the extended range. Show VLAN internal users. You can see there are 4 total VLANs from the extended range. Either it will go in the ascending order or it will go in descending order based on VLAN internal allocation policy, either ascending or descending. If it is descending, then it will go descending. I hope you understand. So either ascending or descending order, it will basically create from 1006 to 4094 or from 4094 to 1000. And whenever I configure like the IP address or when I configure like some L3 commands on that particular interface for the user, for the administrator, it would look like that we have configured the command directly on that physical interface, but that's not true. It would look like that we have configured that command directly on that interface, but that's not true. Actually, for that particular interface, show VLAN internal allocation, show VLAN internal uses for that particular switch port, the switch has created an extended range VLAN and it has configured logically. You will not be able to see the SVI, by the way. There is no show IP interface brief. There is no SVI. There's no VLAN. It will not be shown. It's happening in the backend. It's a logical. It's for the logical calculations. It's happening in the backend. It's not. It's nothing like that. It will show you. But whatever commands that you run, it will run for that SVI for 1006, SVI for 1007, SVI for 1008, and then so on. And you can't create these VLANs now. You cannot create these VLANs. If you try to create these VLANs, you cannot create these VLANs. VLAN 1006 and exit, you can't create these VLANs. See, you cannot create these VLANs. Failed to create the VLAN 1006. VLAN not available in the port manager. Failed to commit to the extended VLAN changes. Port manager, extended VLAN already in use. VLAN 1006 is already in use. So failed to create the VLAN. VLAN is not available in the port. So you can't use those VLANs now. And if you already have created the VLAN, then it will create like 1006, 1009, 10, and 11. So if the extended range VLAN is being used for internal uses, You can't configure those VLANs. You cannot configure those VLANs like manually. And if you have configured those VLANs manually, then this switch is not going to use it for the internal uses. It will not use it. It will use whatever are available. Yeah, go ahead, Chetan. Yeah.
Yeah, one question. So these VLANs, which is created for internal usage. So what is, I mean, I get this, but what is, I mean, how the traffic is going to flow? Because, for example, if the internal usage VLAN is created 1112, right? And we have
Okay.
created a SVI also for the same VLAN,
You cannot do
and
that.
it will not
You
allow me
cannot.
to do so.
Yeah, it is right in front of you. You can't do that. If the switch has used a particular VLAN for the internal uses, you can't actually use that VLAN for your purposes. So you can't create that VLAN. You cannot, if you can't create the VLAN, you can't create the SVI or anything. That will not happen.
Okay, and what is, I mean, what is the purpose for this one, right? It is just only when we create the interface from, switching the mode, that is where it is only used, right?
Yes, correct. That is the only place where you will see this VLAN internal thing or that thing. Yes. iOS like that we have on these switches, for example, they actually do not have any such feature to convert the port directly from the layer 2 to layer 3. So they just mimic that they have become a layer 3. They are pretending that they have become the layer 3 port. They are not the layer 3 port. They are pretending that they have become the layer 3 port. So what happens
But this
that
information never passed to other switch, right? I mean, when the traffic is flowing from this switch to another switch,
uh,
encapsulation will flow, but this information which is showing here, this information will not pass to other switch. Am I correct?
the concept of VLAN stays local to the switch. So VLAN, extended VLANs, and all that thing will remain local to the switch. So if you have connected multiple switches, by the way, it's a routed port now. It's a layer 3 port. So when the packet passes from the layer 3 to layer 3, source MAC address, destination MAC address, all that thing changes, by the way. So it's no longer switching, it's routing now.
Hmm.
So is it? I mean, when we are the more health interface we configure in the switch, like for
Hmm.
example, from 1 to 48, the
Hmm.
more the VN ranges will be reserved from 1006 to all
Correct.
the way.
Correct. So you convert this port into the layer 3 port. The VLAN 1006 was reserved in the backend for the same purpose. And for the VLAN 1006, it also has created the L3 interface, that is SVI for VLAN 1006. So now when you and that IP address 192.168.10.1 is basically configured on that particular SVI, logically speaking. So when you ping from 190 to 168.10.2 to 10.1, packet arrives onto this port. This port is configured as a layer 3 port. For the user, user sees this port as a layer 3 port. For the user in the configuration, it looks like it's a layer 3 port. So, and that port is configured with the IP address of 192.168.10.1. So you will get the reply and you will think that the packet reply is coming directly from that layer 3 port. But however, in the backend, the frame arrives onto this particular switch port. This switch port belongs to the VLAN 1006. For the VLAN 1006, we have configured, not we have configured, the switch has configured an SVI. And on that SVI, it has configured an IP address. You are getting the reply from there actually, not directly from that port, in fact.
Is this the behavior in this EVNG iOS image only, or this happens in the physical
This happens everywhere.
also?
This concept is applicable everywhere. If you purchase a 3550, 3750 series switch, you will see the same exact concept here. iOS based devices, they work like that.
And even if we configure this switch to L3, right, and later on we want to create a VRF, then we have to, put encapsulation on it. So that information will pass, but this information, which we are seeing here,
This is for internal
10006.
users.
Okay.
So this is for the internal users. So this information stays internal to the switch only. You will not be able to see it anywhere. Not in the show VLAN brief, not like in the show IP interface. So nothing you will see that.
Okay. Okay.
And I could have done it like manually as well. I don't really need to do, if I like configure terminal, interface, range, Ethernet 0 by 0 and 3, and switch port. If I wanted to do that, actually, I could have done it like manually as well. If I wanted to do that like manually, then I could have configured a VLAN such as like 999. I could have put the port interface Ethernet 0 by 0, switch port access VLAN 999, and I can just configure an interface VLAN 999 and I can configure 192.168.10.1. It is the same thing, by the way. It is the same thing. It is just that you are able to see all these configurations now, and you have to do like a lot of configuration actually. But it's the same thing as the previous one actually. You could have done it like manually. You could have configured the 4 VLANs like 999, maybe 991, 992, 993, 994. You could have configured these individual interfaces into the respective VLAN, configure the SVI for it, and configure the IP address there. You could have done it like manually as well. But this basically is actually far more easy as compared to doing all that thing. So generally, like using the no switch port command, if you have to use like some layer 3 interfaces or ports, it becomes like very easy to use just no switch port command and directly start configuring the VLANs, and the switch will do internally some things to map that physical interface to the extended VLAN, to the SVI, or whatever it needs to do. It will do it in the backend. So the admin doesn't need to do all that thing manually.
Has the switch accepted this command as descending or ascending? Because so it assigned port, VLAN 1006 for that port.
By default, it's ascending. You can change it to descending as per the requirement. Like
VLAN, that's why you in the history you see above in the
because I run that command earlier. I run that command in
VLAN should have been assigned from VLAN should have been assigned from 4006, isn't it?
Yes, correct.
But it was assigned 1006.
No, I run the command later on. I already did the no switch port, and I run the command later on. Basically, that's why VLANs are still assigned from 1006. But if you run the command like descending and then you convert the ports into the layer 3, then you will definitely see 4096 and so on. You can test it in the EVE-NG. And this is the exact same thing that you will have to do. This is the answer. This is, by the way, is the answer to the question, what if I have to do the same thing on the layer 2 switch? What if I have to configure some IP address on the layer 2 switch? If you have to configure some IP address, if you have to, let's say, for example, configure the IP address on the layer 2 switch, you can't directly do it. You can't directly do it on the ports. Actually, you cannot directly do it on the ports. By the way, if you want to do that, for example, do that, then you have to configure, for example, a VLAN. I have configured here, for example, VLAN, like maybe VLAN 999, whatever. I have configured a VLAN such as, for example, 999. And I have put the port into that VLAN 999, and then I will configure an SVI. And once I configure the SVI, once I have configured the switch virtual interface, once I have configured the SVI, I can configure some IP address on there. But this thing that we have will definitely have some limit, like how many number of SVIs we can create on a layer 2 switch. Maybe like that will have some limit. Might be like you might not be able to configure more than 1 or more than 2 SVIs, for example, because layer 2 switches are more like they are just used for the layer 2 purpose, like forwarding the data based on the MAC and all. So it's mostly based on the MAC address. Why would we configure like an SVI on there? It is mostly for the management purpose. So ideally, if we have to do the similar kind of thing on a layer 2 switch, what we have to do, you can create on a layer 2 switch maybe a VLAN, like enable config. If let's say, for example, all these users wants to take the access of the switch, and all these users are part of the VLAN 1, I can directly go on the interface VLAN 1, and I can configure it with some IP address, such as 10.1.1.1 maybe. I can do the no shut. Although I don't need to do the no shut, but here in this simulated environment, we have to do the no shut as well. So I know that all these ports, they belong to the VLAN 1. So I can configure an SVI for the VLAN 1. I can configure some IP address there, and I can maybe enable like the telnet or SSH, like enable secret Cisco line VTY 0,4 password Cisco login IP DHCP. I can configure DHCP services, IP DHCP pool, for example, VLAN 1, and IP address like 10.1.1.0, then IP address, then default gateway DNS and all that thing we can configure. But you can see that there are limitations. You can see there are limitations that, for example, this particular switch platform, since it's a layer 2 switch, it will not understand the layer 3 commands. So the only reason I will configure an SVI, the only reason that I have configured this SVI, by the way, this SVI, the only reason that I have configured show IP interface brief, the only reason that I have configured the IP address on that VLAN 1 is that so that we can manage this switch, so that we can manage this particular switch from these users. I can configure the same IP address, same range IP address there, like 10.1.1.2 maybe to 55.255.255.0, and I can definitely do from the command prompt, I can definitely do the ping 10.1.1.1. Then I can do the ping, I can do the trace, I can basically do the telnet. You can see the ping, the flyers coming. I can do the telnet 10.1.1.1. So will you be able to create more than one SVI? Like for example, VLAN 2 interface, VLAN 2 IP address like 20.1.1.1, no shut, for example. So can we configure like more than one SVI on that switch platform? Maybe some users are in VLAN 1, some users are in VLAN 2. VLAN 1 users have the IP address of 10.1.1 range. VLAN 2 users have the IP address of 20.1 range. And both of these users wants to take the remote access of the switch. So I configure two SVI there, SVI for VLAN 10, SVI for VLAN 20, SVI for VLAN 1, SVI for VLAN 2, for example. Show IP interface brief. I have both the SVIs up and running. So if the user belongs to VLAN 1, they can take the remote access of the switch. If the user belongs to VLAN 2, then they can take also the remote access of the switch. But if you do the same exact thing on a real switch, if you do the same exact thing actually, if you do the exact same thing actually on a layer 2 switch, by the way, on a physical switch, you will notice that when we create when we create a new SVI, the other SVI will go down. These L2 switches that we used to have, these L2 switches, they more like had a limit. They had a limit on like how many number of SVIs and all we can create, we cannot create. They more like had some limit actually. But here in packet tracer, it's not a big deal. And like we covered in the last class, like most of the switches that we have in a modern day network, these are capable, these are equipped with both L2 and L3 functionality. So pure L2 switch you might not even see actually, not a big deal. But since we can't convert the port from L2 to L3, if you want to configure an IP address on the switch, it is a good idea to configure some VLAN, such as VLAN 999, interface like VLAN 999, for example, that we are going to use for description, like MGMT, management purpose, like management VLAN, for example, and then configure some IP address there, like 192.168.99.100, for example. And whoever basically, whatever devices, whatever users are basically authorized to take the remote access of the switch, you can tell them the IP address that you can access it via this particular. Generally, we have a dedicated VLAN for the management purpose. Sometimes you might see the VLAN 1. Sometimes you might see some other VLANs for the management purpose, but VLAN 999, 100, 200, whatever, in your production environment, if you are using a layer 2 switch, there will definitely be some VLAN that you might be using for the management purpose. Not always like it's not like it's always going to be VLAN 1. It could be like any. And it's better actually. Instead of converting all these ports into the layer 3 port and then assigning them with the IP address, it is better that you put all these ports into a VLAN and configure the IP address on that particular VLAN. Configure the IP address for the SVI rather than doing it on per port basis. Because if you convert all these ports into the layer 3 ports and try to configure the IP address here, try to configure the IP address here, you will need more than one subnet. You cannot configure the same subnet IP on 3 interfaces. You can't do that. If you remember the rules of routing, if you remember the rules of like the IP addressing, you cannot configure same subnet IP address on 3 interfaces of the router, of the switch, of the firewall, of any device. It will create the issue in the routing. So if all these users are admin users, and for the admin users, we have designated the subnet 192.168.10.0/24, and I want all these admin users to be able to access the switch via telnet, via SSH maybe. And for that, we are going to convert the port from the L2 to L3. That's not going to work, because if you convert this port from the L2 to layer 3, sure, you can configure the IP address from that 192.168.10 range. But you then cannot configure the same IP address, same subnet IP address here or here. You have to configure maybe 20 or 30, so it's not going to work. Better that you put all these ports into a VLAN and you configure the IP address on that particular VLAN, meaning to say that whoever belongs to that particular subnet will be able to take the access of that switch for the management. That will be much better option. But anyway, I'm not saying that we will never use the L3 interfaces. Maybe there is a port of this switch that is going towards, let's say, for example, a router. Here, for example, there's a port of that switch that is going towards, let's say, for example, a router. And I already have configured some IP address on the router. And I want some sort of routing functionality between these two devices. Definitely, we can convert it into L3, configure some IP, and then sure, we can configure some routing. So you have to choose. You have to decide. It's not like me telling you that, okay, this port has to be L2, this port has to be L3. It is you have to decide, like, based on your production environment, based on your topology, whether if I want to provide the remote access capabilities to all of these users, VPC 6, 7, 8, 9, it's not a good idea to convert these interfaces as the L3 interfaces into L3 interfaces because then we will require more than one subnet. It would be a good idea that it will be a good idea that you go on the switch number 1, configure a VLAN such as 999 or whatever, and you configure an SVI for that VLAN and configure it with the IP address of the subnet that we have assigned on these users. And sure enough, like, these users can then take the access using that particular. So choose it. Choose whether you are going to use the no switch port command or you are going to use the SVI option. You cannot create those VLANs that are being used for the internal uses. You can change the VLAN internal allocation policy from ascending to descending. And then when you create the VLANs, it will show the VLANs from 4094, 32, and all. So the options are basically available. And whatever we have discussed so far about this backend functionality is not relevant to the current switches. It's a thing in the past. In the current switches, in the current lineup, current platforms such as 3850, 3860, or like these 92, 93, the current switches that we have, for example, they do not work on this concept actually. So in the current platforms, for example, current switches that we have, for example, like if you are working on a layer 2 switch or maybe a layer 3 switch, whatever, if you are working on the layer 2 switches or the layer 3 switches here, for example, I have taken the access of a real switch. It's, by the way, a 3850 series switch. It's a 3850 series switch. Show version. It's a real switch. Since I'm here in office, I can take the access. So it's a Catalyst 3850 series switch. It's a Catalyst 3850 series switch. You can see 3850 series switch. And you see that here, show IP interface brief. You can see that here we have converted these ports into the L3 ports, for example. We have converted these gigabit 1x0x23 and 24 ports into the L3 ports. You can see the IP address, for example. And use the command show VLAN internal allocation command is not there. Allocation policy, there's no such command. There's no use of that extended range VLAN or anything. Nothing. Modern day switches that we have, Catalyst 92, 93, 38, 50, 60, modern day switches that we have, they handle this thing. They handle this L2 to L3 conversion like completely internally without creating like any extended range VLANs or anything. These modern day switches, basically, they do not need to create those extended range VLAN and all that thing. They don't need to do. They work quite similar to those interfaces start working quite similar to the router interface. Like to the router interfaces, basically, they don't use any extended range VLAN or any such thing. They don't do that. So these commands, VLAN internal allocation policy or show internal uses, you will not be able to see these commands on the modern switch platforms like again, same 9000 series switches, 3850, 3860. The hardware basically has evolved so much. The ASIC, the application specific integrated circuit, the UADP, the Silicon One, it has evolved so much that they can handle this conversion from L2 to L3 and vice versa internally without the need of like any switch port, no switch port. But if you still have some old switch platforms such as 2950, 2960, and you or 3550, 3750, for example, and you run those commands there, you will definitely see 100%. You will see that. So this information is completely irrelevant. This is useless. But you should know it. You should be aware of it, because maybe you are working on some old switch platforms and you are not able to create a particular extended range VLAN. There could be a reason that that VLAN is being used for internal users. Maybe that switch still uses the concept of that internal VLAN. It uses the concept of those SVIs and all that thing to perform the mapping and all. So from the modern day network point of view, this information is completely useless. But this is how the traditional switches used to handle that conversion from L2 to L3. And although we do not have a pure L2 switch in a modern day network, even a basic Catalyst 9200 series switch will come with some routing functionality where you can configure the ports directly from L2 to L3 without any issue. So these things will not be relevant on those new switch platforms. That is also mentioned, by the way, here at the very end, that you will not see these things, these commands on modern day. But at least you should know the backend process of this conversion. And if you don't have, by the way, if you do not want to convert like all the ports into the L3 to configure the IP address, then definitely you can configure the SVIs. If you, for example, do not have a layer 3 switch, let's say you are still working on 2950, 2960, how are we going to give the IP address to the switch so that we can take the management access and all that, telnet SSH, because these commands are only available on the layer 3 switches. So what we can do, we have n number of interfaces. We can configure those n number of interfaces in a VLAN. We can configure an SVI for that VLAN, and we can give that IP address to that SVI. SVI, or switch virtual interface, is a virtual layer 3 interface for the VLAN. VLAN is a layer 2 concept, and SVI is a layer 3 concept. SVI is in fact the layer 3 interface for the VLAN. SVI is a virtual layer 3 interface for the VLAN where we can configure some IP address so that we can easily manage the switch, maybe from the remote access point of view, maybe from the telnet SSH point of view, maybe from the DHCP and all that things point of view. We can do the management of the switch respectively. If you want, you can use VLAN 1 for the management purpose, because by default all the ports are in VLAN 1. It will be easy to manage the switch from any device, but using VLAN 1 for the management purpose is going to impose some security challenges. So we generally consider using some other VLANs for the management purpose. And SVI is not a concept of a layer 2 switch, by the way. SVI can be configured on both layer 2 and layer 3 switches. And like later on, when we study the concept of VLAN, trunks, when we study the concept of inter-VLAN routing, you will also see that these SVIs that we have created on the switches, they might act as the default gateway for the end user in case of like things such as inter-VLAN. So these are the physical interfaces that we have. There are physical interfaces that we have, and there is this logical interface, this virtual interface that we have on the switch platform. Apart from that, we also have the loopbacks. We can definitely create the loopbacks on the switches. I can go on the switch and I can configure maybe some loopback interface. I can configure it some IP address. I can use this loopback interface for various things such as maybe like BGP neighborship, maybe like source of the NTP messages. Maybe this switch is acting as the DHCP server, and I can use this loopback interface for the relay agent and all. We can use the loopback interfaces for like several purposes. And since we do not connect, or we cannot connect any physical device onto that loopback interface does not need a whole subnet. Only one IP is sufficient on the loopback interface. That is why the loopback interfaces are the only interfaces where we can configure the IP address on a /32 mask. Like, we can't really configure like we cannot connect like any like PC or anything on that loopback interface actually physically. So we don't need 2 IPs or 3 IPs. Loopback interfaces, they generally need only 1 IP, and 1 IP we get on /32. So you will see that in most of the environment, the loopback interfaces are configured on a /32 mask. It will definitely save some IPs. And if you have like many loopbacks configured on the particular switch platform, you can configure the IP address from the same range, like interface loopback 2, IP address 1.1.1.2, because 1.1.1.1/32, 1.1.1.2/32, 1.1.1.3/32, these are all 3 different networks, 3 different. So loopbacks we can also have. Later on, you will study port channels. When we talk about ether channel, then you will study that we can have port channel interfaces also. These are like the virtual interfaces that we. So the ports, the interfaces, physical, the logical. Where to configure I will give you a general idea. like for example, there is a switch and there are users going towards like, and there are like ports going towards end devices. Generally, these ports are going to be layer 2 ports configured with some VLAN membership. And then maybe we have some upstream switch as well. We are going to configure that port maybe as a trunk port. Maybe we have a router here. We can configure the port as the layer 3 port so that we can configure the routing. So from the design perspective, you have to decide where we have to configure the L2 ports, where we have to configure the L3 ports. From the design perspective, you have to decide like the use of the L2 ports and the L3 ports respectively, which will get more clear later on when we start discussing about the design, which is our next topic. But the general idea basically behind the L2 and L3 port is like anything, any questions? Let me know. Most of the things you might already, you might already have known like from this discussion. I believe like you already know what is loopback, you already know what is port channel, you already know what is SVI, maybe, but a few things like you might not know, so it was important to go. I hope you already know that when we have to access the switch, you have like console port. You can do the remote access. Like for the remote access, you have VTY, virtual terminal yard. You can use the console cable, connect it on the console port, and then you can take the access from the computer terminal using that console port, console cable. Different types of console ports are there, like USB console is there, like normal, like, the LAN type, the console is there. Nowadays, we also have the USB console by the way. So on the switches, if you notice, on the switches, we have some USB console as well. Basically, console port, or maybe like you can have that, that regular console port actually as well. So we can use the console port using the console cable. We can actually we can start managing the particular switch. We can take the access of the switch using the console port, console cable. In some switches, there is also a port called management port, MGMT. There is also a port in some switch platforms that is dedicated for the management purpose. In some switches, we have a dedicated port for the management purpose, such as this one. In this particular switch, this is a 3850 series switch. We have a port called gigabit 0 by 0. This port is specifically for the management purpose. It's a LAN port, by the way. It's a LAN port in the back of the particular 3850 series switch here. So here we have console in the back of that 3850 series switch. This is the back of the 3850 series switch. Here we have the console and here we have the MGMT. So if you have a console cable, then you can connect that console cable to the console port and you can take the access. And if you have a simple LAN cable, then you can basically take the access of that particular switch via some IP address. You can configure the IP address on show run interface gig 0 by 0. You can configure the IP address on that. You can configure the IP address on that particular management port, the MGMT port, and then you can take the access of that particular switch using the particular IP address, like telnet, SSH, and all that. And to make the management traffic separated from the data traffic, that particular port is by default put in a VRF. I did not configure it, by the way. It's the factory default settings. VRF is like VLAN. Just like using the VLAN, we can do the segmentation at layer 2. Using the VRF, we can do some sort of segmentation at layer 3. I want to isolate my management traffic from the regular data traffic. So I can put that interface, that management interface, basically into a dedicated VRF. I did not configure it. The switch came with that VRF by default. The switch came with that configuration by default. I did not configure it. So on this switch, some interfaces are part of like global, and some interfaces are like part of VRF. Whatever traffic arrives on the VRF will not go into the global. Whatever traffic arrives on the global will not go into the VRF. So separation is there. But you will need the IP address there. Maybe these are all like the switches that we have in my production environment, 3850 or whatever, 92, 93, whatever switches we have. We have like multiple switches in the production environment. And I really cannot configure a console. I cannot connect a console like everywhere, hanging from that particular switch. So that we can take the access. What I can do, on all these switches, we have that management port. On all these switches, we have the management port. Maybe I can connect all the management ports from a management switch, and then I can connect a user there so that the user can take the access of these switches via the IP address that we have configured on that management. And configure terminal, default interface gig 0 by 0. Default interface gig 0 by 0. So do show run interface gig 0 by 0. See, so this is the default configuration. You can't remove that. You can't even remove that VRF from that management interface actually. Maybe while doing the initial setup, I can configure some IP address here, some IP address here, some IP here, some IP here, or better, interface gigabit 0 by 0, IP address DHCP, so that it gets the IP from the DHCP server. But then you will not know the IP. I hope you get the idea. So you will not know the IP, what IP you got on the switches. It's always a good idea that you configure a dedicated IP on this management port so that you can take the access via the console, via the PC terminal. So we have like the console ports. We can have like USB console. We can have the regular console on the switches. We can have a dedicated management port on the switches where we have to configure some IP so that we can take telnet SSH access of that switch. Also understand that when you take the access of the switch, either you will get this CLI based access of the switch. Maybe you are using the software such as PuTTY, Secure CRT, Hyperterminal, TerraTerm, whatever, Super PuTTY. Maybe you are using certain software such as PuTTY, Secure CRT, or any such software. And using that software, you are taking the access of that switch and you are doing the management of that particular switch. CLI, command line interface, which is okay. Fine. But it is all, if you have like, let's say in your production environment, if you have like 10, 12 switches, for example, in different, you have for example, a big building where you have like several floors. In every floor, you have some switches, then you have connected all of them together with some switches and then so on and on. Let's say you have only 10, 12 switches in your production environment, in your building. You have configured some IP address on the management port, or maybe you have decided that you will use the console port for the management purpose. Accessing all these switches like one by one is of course like going to consume some time. Accessing these switches like one by one and doing the configuration will definitely take some time. So especially when we talk about CLI, the command line interface, CLI, like we can take the access of the switches via some PuTTY, Secure CRT, or these kind of applications. From there we can do the management configuration, whatever we need to do. That might or might not be the best approach. What you can do, you can enable on the switch platform, you can enable, HTTP, IP HTTP server, IP HTTP authentication local, and username like, what is that? Cisco, maybe? Privilege, for example, like 15, and secret password like Cisco @123. Line, remote access, VTY 0,4, login local, and transport input all. That means I'm going to accept all the input. Maybe HTTPS. We can enable the HTTP or HTTPS IP HTTP secure server. Maybe you can enable HTTP or HTTPS. Maybe you can enable the HTTP or HTTPS, IP HTTP server or IP HTTP secure server. We have enabled the HTTP or HTTPS services onto this switch. Doesn't mean that this switch has become the internet. It's not like it has become internet or it has become part of the internet. What does this mean? We configured the HTTP services, we configured the HTTPS services onto that switch platform, and then we have configured the authentication, IP HTTP authentication local, which basically means that now this switch can also be managed via HTTP or HTTPS over the web browser, a browser-based access, a web user interface, not CLI. A web user interface based access can also be provided for this particular switches. For these switches, basically switches, routers, all of these devices. And you can do a whole lot of things actually from that web-based user interface, right? For example, if I open 192.168.10.1, this is that 3850 series switch that we have. This is that 3850 series switch that we have here. This is the 3850 series switch, this one, the management switch, this one. I already have enabled the HTTP, HTTPS services. This is that 3850 series switch that we have configured with IP, and we have also enabled the HTTP, HTTPS services so that this switch can not only be managed via the CLI, but it can also be managed via the web user interface, web UI. Graphically, again, this is a very old switch platform running on old version of the operating system. If you're working on new version of the switches, new version of the operating system, you will see pretty good like this user interface. Actually, more and more options you will see. But you can, for example, from this web user interface, graphically you can actually check several things from here. Graphically, you can check several things from here, like memory utilization. You can check the CPU utilization. You can check the basic device information, like the iOS version, the time and time zone, and whatever, temperature. It's running 23 degree. Okay, fine. You can also see the switch view from here. How many ports are up, how many ports are down. You can see the duplex. You can see the stack. If you have configured the switch stack, you can see the speed. They are operating at 1G, 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 1 gigabit, right? So you can see some basic information. From here, you can customize this dashboard to show more or less information as per the requirement, So information gets refreshed in every 300 seconds, in 30 seconds. In 300 seconds, you can tune up how fast the information will refresh. Yeah, you can configure the timeout and all that thing basically. And not only you can monitor the things. This is just the basic monitoring. Not only you can this is the main dashboard. You can also monitor several other things. Like for example, CDP. You can monitor, for example, how many neighboring devices are there. For example, you can monitor like the DHCP clients. Are there any clients getting the IP from the DHCP? Yeah, looks like a lot of clients are there. The ports that we have onto that particular switches. What are the ports interfaces we have onto that switches? You can see that. I can click on a particular port, by the way, to get more detailed information about it. Generally, the things for which like you have to run the commands, by the way, like, generally for the things that you have to run the commands, you can just check it graphically from this dashboard. STP, for example, you can check the STP, spanning tree protocol for VLAN 10, VLAN 20, whatever VLANs you have configured. This is monitoring, by the way. This is you can monitor from this centralized web user interface. And not only you can monitor it, you can also configure a whole lot of things actually from this web user interface as well. Like not only you can monitor it, you can also configure configure the logical interfaces such as port channel, such as loopback. These are considered as a logical interfaces, the port channel interface and the loopback interface. We can configure the port channel, we can configure the loopback interfaces as per the requirement. Configure it, we can add the interfaces for which we have to run the commands. We can just click on add button and we can configure the loopback number, IP address, and a whole lot of things. We can configure the span, STP, VLAN, VTP, routing protocols such as EI, GRP, OSPF, for example. We can configure all these things like from this dashboard itself. Over the HTTP, actually, it is possible to do all these, which for some people are much more better actually. Like some people might prefer to work on the web user interface rather than the command line interface. So this is more like for them. You can configure the IP address on all the switches that you have, and then you can just open the browser and start accessing each and every switch one by one. In fact, we can check the logs. We can check the logs and a whole lot of things actually on here. We can go on the administration. We can run the commands from here. Administration, we can check the device information from here, SFTP, FTP server, and all that. We can configure the DHCP pool, DNS. We can reload the device. We can configure the users. We can do the troubleshooting. We can check the logs from here actually. This web user interface, if you want, you can explore, but this web user interface will provide you with like plenty of options to monitor the device, to configure the device, to troubleshoot the device, like plenty of things basically you will be able to see here. You can do the ping and trace, for example. You can do the packet capture, by the way, for example. You can do the embedded packet capture. You can run the packet capture from here, and you can download the PCAP file for the analysis purpose. So this web user interface is just another way. This web user interface is basically just another way to actually access the particular switches, particular like these modern day switches that we have. So if you don't want to work on the CLI, you can definitely use the web user interface. You can use the web UI, web user interface actually. You first configure the HTTPS services, and then you can just use the web browser and you can do the things from there actually. That also, if you don't want to do it from the CLI, you don't want to do it from the web user interface. If you have like more and more switches, let's say we have 20-25 switches, for example, in one of the site. Similarly, we have like 3-4 sites. We have 3-4 sites, or maybe 5 sites, or 4 sites. We have like 100-200 number of switches, for example. and we can't possibly configure all the switches via the CLI. And of course, we can't take the web user interface access, web UI access of all those switches actually as well. Well, we can do that, but it will definitely like take more and more time. So if you don't want to do that as well, then finally you will have the option, just like in a wireless environment, if you have, let's say, for example, multiple access points, if you have, for example, multiple APs, if you have, like, for example, multiple access points, you can actually manage all those access points from a centralized controller called wireless LAN controller, WLC. Similarly, in this environment of switching, in this campus local area network, in this campus environment, in this case, if you want to manage all the switches from a centralized controller, then you can go for that software defined LAN concept, or you can go for software defined access concept, as the WAN, as the LAN, or as the access, as the A technology or as the LAN technology. It is targeted actually on this particular part, that that it gives us the capability to manage all the switches from like one centralized point. If you want to manage like all the switches from one centralized point, you can use this SD access technology. You can purchase and install a controller, just like you purchase and install a controller like WLC. However, it now comes in a software format as well that you can run on the ESXi. So controller, however, if you want to manage all the switches from a centralized point, not via the CLI, not via the web UI, if you want to manage all these switches from one centralized point, you can do it with the help of a centralized controller that comes in this with this SDA solution. That controller name is basically DNS Center, Digital Network Architecture, DNS Center, which has been renamed now to the Catalyst Center, which will give you the ability. It will give you the ability to manage more and more devices from a centralized dashboard. For example, in this demo, you have this Catalyst Center. This Catalyst Center they have here, it is managing approximately 83 number of switches, 83 number of devices on 61 different sites. It's not a DNS Center class, so we're not going to talk a lot of details about it. But you can see that we can use this software such as Catalyst Center. We can use the centralized controller, the Catalyst Center or the DNS Center, and we can manage all the devices like switches, for example, from a centralized point. There are total approximately 83 number of devices, including the switches and including the wireless device. We can manage both wired and wireless network of an organization via this centralized controller called DNS Center or Catalyst Center. It supports different platforms. You can see the industrial Ethernet switches are also supported. You can see some Catalyst the switches are also supported. You can see these kind of, whenever you study the SDA later on, you will know what devices are supported, what not. But you can, for example, click on the device. You can check the complete details of the device, like view the device detail. You can check the complete detail of the device. You can check the overall information, overall health and all that information of that device. You can run the commands from here. If you want, you can run the commands from here, like show IP interface brief. You can run the commands from here. You can whitelist, blacklist the command, what commands you can run, what commands you cannot run. Okay, so most of the commands they have blacklisted. What commands then we can run? We have some basic ping trace commands basically. Show commands we have, but not sure what show commands they have. Show commands basically. Show commands they have, but not a lot of show commands they are giving us the access. This is the demo, by the way. So we can run the commands from here actually. We can get the detail. We can check the basic information about the switch right from here. We can check the detailed information about the switch here. We can check the detailed information about the switch here. So like if you do not want to like manage the device like manually via the CLI, via the web UI, then a software defined approach to manage the campus local area network is also there, which is what they refer to as the LAN, software defined LAN or software defined access in terms of Cisco. From here, you can it offers like plenty of functionalities. Whenever you study the SDA classes later on, you will learn about it. But it offers like plenty of functionality. Not only we can monitor, Not only we can monitor, but we can also configure a whole lot of things. We can configure the policies from here. We can design the whole network from here. It offers like plenty of things. There are several tools to discover the topology completely automatically without any human intervention, anything. The point remains the same, that if you want to manage the devices from a centralized point, you will have to go for some controller based networking, some software defined networking. And that software defined networking you will be able to implement with the help of this concept called this controller called DNS center, also known as the catalyst center, which you will be able to understand later when we start the DNS center catalyst center classes. It's currently hardware, so Cisco has started like selling this as a hardware appliance. It does come with the software, but as a software, but you can't mimic it or you can't simulate it in EVNG. So you can't practice it in your home environment. If you want to explore the options of the Catalyst Center later on we talk about it in the SDA classes, you can visit the Cisco D Cloud. In the Cisco D Cloud, they have like several demos. One of the demo that they have is the Catalyst Center, the DNS Center. From there, you can it's always on, so no reservation required or anything. You can just explore what options you get in the DNS Center. Otherwise, like whenever you start the SDA classes later on, it will be covered anyway. At the moment, the objective was to tell you that not only we can manage the devices via the CLI, we can also manage the devices via that centralized control. These are the ways to access the device, like access the switches specifically, the console, the USB console, the management, the CLI, the web UI, the centralized controller, and all that. We have several ways using which we can access or manage our switch platform. You have to choose where you have to use the L3 interfaces. You have to choose where you have to use the L2 interfaces, the VLAN, the trunks, the IP addresses, and all that. You have to choose, which we will cover in our next topic. Our next topic is, by the way, the design. The next topic is, this is done, by the way. You can practice it now. You can practice converting the port from L2 to L3, L3 to L2. See what changes are there. See if you see that VLAN internal users command in the real devices or in the EVNG or not. Try to change that from ascending to descending. Do whatever things we have discussed today. And like now we know the basics of the switch. We now know the basics of this switching. We now know what are switches and all that different types of switches. Now we are ready to build a campus network. We are ready to now build a campus local area network, a campus area network, the 2-tier model, the 3-tier model, the STP based, the routed access layer, and all that. We'll spend some time. I believe upcoming two classes we will spend in our designing the campus area network, and then we will move on to some practical stuff. We'll talk about like the functions of the switch, address learning, filtering, formatting, etc. This is again today also like it was just the basics. No like proper lab that we can just repeat whatever things we have done regarding L2, L3, and then we will continue from here tomorrow with the design section of our.
I had one query.
Yes.
Actually, so this Cisco IOL images. So I'm using a Mac.
Okay.
So this IOL images are not supported in this particular Mac. So is there any alternatives?